Opening prayer. You're praying?
Yes, that will go to it.
Okay, in the name of the Father, and of the Son, and of the Holy Spirit. Almighty ever living God, Lord, thank you for the gift of this morning. Father, as we are going to start this day, we pray that you guide us, give us the knowledge, give us the strength, so that we become confident. We make our prayer through Christ our Lord. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Thank you so much. Thank you, Ms. Erisa. I think we are good to start.
Yeah. So now, sir, I think you're having the first presenter.
Okay.
Yeah.
Yes, good morning, member. Good morning.
Morning, sir.
This is Mbale Mbale Secondary School, Senior 6 Science A. You are welcome in our seminar. That is Interschool Virtual Seminar Mathematics 2023. And I'm taking you through question number 2, which is all about, it is from the topic of algebra. And it's saying that the first 4 terms is the binomial expansion is given. So we have our binomial expansion, which is 3 plus kx power 5 in ascending powers of x can be written as, so they gave us the expression, which is a plus bx plus cx squared n plus b x cubed. So they are telling us that the first 4 terms of that binomial expansion can be written in this form with the ascending powers of x. So at A, they wanted us to get the values. They have first of all told us that B is equal to C. So it is an important information in that question. Then they wanted us to find the value of K. So we shall first of all expand in our solution to part A. We shall first expand the binomial, this expansion here, until we obtain the first 4 terms. So this one calls us to go back to, in the what? We shall need here the Pascal's triangle, because we are going to expand up to the highest power is 5. So we shall say the side work shall first identify our coefficients, which we start with 0, then we go to 1, then we go to 2. I hope every person knows how to get it. Go on 6, then lastly 5. So these are the coefficients that we are going to use, that expansion there. So we shall start. We know that in the binomial expansion, the first always may take it to be A and then B. That is the easy way of expanding that thing there. So it will become the first term here. It will take all the power, while this one will be at 0. So that one we shall have 3 power 5 into kx power 0. Power 0, then plus. So we shall go on reducing the power of the first term, which is a 3, and then go on increasing the what? The power of the second term with its powers. So here we shall have our coefficient is 5 into our 3, which has reduced now to 4 because it is 5 minus 1, into our kx, but 1. So this is the second term. Then the third is the coefficient is 10 into, we go on reducing into increase. Then this is 1, 2, 3. Then the last one, it is 10 into, because the second coefficient is 10 into 3, but squared to x cubed. 10 plus the remaining, there is another term remaining there, so we could not stop there because it is the power 5. So for us, we have stopped at the fourth term there. So as you see, therefore, then we shall go on now, simplifying it, and we see. Yes. So 3 power 5, that is 2, 4, 3. This one to power 0 is 1 normally, yes. Then shall have 3 to power 4, then times our 5, which is 405k x, because this is to power 1. Then 3 to power 3, that is 27 times 10, which is plus 270.
Mr. Erisa, we have lost you.
The 3 to power 3, we got 27, then we multiplied it by 10, got to 70, then k squared, x squared. Then also here, which is 3 squared, and that is 9 times 10, which is 90, x, k cubed, x cubed. That's those ones there. So now they told us very well. They told us that those first 4 terms of this expansion here can be written in this form, implying that, but from part A, they told us very well that B is equal to C. So we shall be able to identifying what? Our values of A. A is 243. B, so here the coefficient of x is 405k. Then the coefficient for x squared, that is C, which we have 270, that's k squared. Then lastly, our D, the coefficient with the x cubed, which is now 90k cubed. So from this statement here, that's A, which was given that B is equal to C. So we shall base on this. It was an important information because we are going to use this expression here to get that value of K there. So B, from here we have seen that our B is 0.5, okay, which is equal to our C, which is 270, okay, but squared. So from here, it is a quadratic equation. I hope you have seen there. So it is also okay to collect like terms. I think this one can go the other side. I will have 270k squared minus this one has gone the other side. Okay, it is equal to 0. So I can factorize out and I get k into 270k minus 405, which is equal to 0. So now there, I think our first value of k can be 0. Then it is either k is equal to 0, and then or our 270k minus 405 is 0. So we take the other side to have 270k equal to 405. So our k will be 405 over 270. So our k will be equaling to divided by 270. So shall have 3 over 2 as our answer. So as we conclude, since they told us very well that we just find the value of k, not values, then our value of k, therefore the value in the conclusion, we shall only take one value of k, because if they say the values, then they must be 2 or above. So for this case, they said the value, so implying that the value of k, is shall conclude like that. That is our final answer for part A. So part B, they said that we hence find the value of B. So for that hence part B, the hence part, you have to stop where you have to start from where you stopped on the above solution. So after us finding the value of k, we shall need to continue and we get our D. So already D here, from our comparison, somewhere here at this step, we had to get the values. We compared this and this one. So we came up and said our D is equal to this one. So since you have the value of k, then our D will be the 90 k cubed. So our D, okay, but k from the above is 3 over 2. Then our D is equal to 90 into 3 over 2, but 2. So there we shall have 90 D. D is equaling to, this is 27, 90 into 27 over 8. So when we press our calculators, the value of D there will be 27 times 90 and divided by 8. So in fraction form, the value of D, it is better you put in fraction form because your name is so limited, because you may put the least number of decimal points and the cross usage is better you leave it in a fraction form, which becomes 1, 2, 1, 5 over 4. So with this case of either part, it means the student can also just say from here, we divide it through by k, then by k, so that we reduce, and then you just come at this step there. It is also because they said we find only the value of k, not values. So for me, I just saw that it is a quadratic, but in the conclusion, you make sure that you only get the value of k alone, one value like this that can satisfy the above expansion there. Yeah, thank you. That was the number, question 2. Anyone with a question there?
Thank you so much, presenter, for that wonderful presentation. You have really explained it very well, and I feel it is very, very okay. But maybe what we can share is that when it comes to your name, you need to tell them that at times they may trick them and tell them that write it to these numbers of decimal places. So you assume that a student has written to a given number of decimal places. Which ones would you recommend them to stop at?
At least a maximum of 4.
Perfect.
Because in our logo, our UNEBU mathematical logo books, mathematical logo books, they are given normally to 4 DPs. So that's why we round it to 4.
Okay, very good. Assume that also a student is not aware, maybe he has forgotten, because remember always we have that kind of anxiety when we are in exams. At times we panic and we may make a mistake in expanding our binomial expansion. Where can we find it?
Like, pardon?
Where can we find that binomial expansion? Because at times students make mistakes, they are panicking. So where do you think?
Okay, you can refer to the logo book, mathematical logo books, because it provides all the formulas in mathematics that a student can use to calculate a given function.
Okay, do you have one there?
Yeah, I have it in the bag. Let me pick it.
And then you share with us the page where we can find it.
Okay. So here it just gave the binomial expansions, the general term, on page 60.
Okay.
That was page 60. They just gave us the what? The general term of the binomial expansion with its formula. So for us here, we were interested in the what? In the Pascal's triangle. Yeah, because now this one, for me, according to me, it's somehow, if we have this power n. So this n can mean any integer from 1 to even 0. Even 0 is there. So yeah, it is the same. It is the same.
Kindly write for us the whole expansion, because there are some students that actually don't know. So write for us the whole expansion.
Okay. So for this case, you know very well that the n, this x will take the whole power with a coefficient of 1. That's a coefficient of 1, and then it will take the whole power n, while the y will be at 0. Then the next, we shall now drop this n. Let me see here. N, then x to power n minus 1, then y to power 1 over 1 factorial, then plus. So the n, it will fall again into n minus 1. Don't know whether still I can rub here.
Okay.
Mr. Kazi, can I rub?
Okay, no, right up.
Okay, sir.
Okay.
So we have x plus y power n is the same as we have our x to power n, because then some maybe let me highlight on this. To get this x power n, we can still use the binomial itself, because we shall say n combination, we are starting from 0. So if we say n combination 0, any integer here, that n there, it will give us a coefficient of 1. That's how we can come up with those coefficients that I'm saying that there is the 1 there. So I hope their members can get it. Then our y is power 0, then plus the n will drop. Then we reduce the power of n by 1. Then we increase the power of y by 1. Then plus still this n. And now this one is the one to drop. And you find there this n, which will be n minus 1 into. But remember, this is 1 factorial. Of course, 1 factorial is normally 1. That's why don't bother. So here x to power n minus now 2 power y to power 2 all over our 2 factorial. Then plus, you can go on like that. So this one you drop shall have n minus 1 into n minus 2. So we shall have x power n minus 3, y power 3 all over 3 factorial, then plus many others, many terms up to, we can even go up, let me say, to infinity. Yes. So I hope every member knows how to get these factorials. Yeah, for a factorial given like this one shall simply multiply there by 1. Then this one will be 2 times 1, which is still 2. Then this will be 3 times 2 times 1, which is 6. So that is the general here given.
Okay, kindly, I want you now to relate that formula to what we were given, such that we can come to this step of yours.
Okay. So from this formula, our x, if we identify those variables, the n will be 5. I hope, let me write it. The n will be 5. And then the x will be 3. And then the y will be k. x. Yeah. So if I can feed in the formula, it will become from here. We are here now. Let us not bother the other side. It will be 3, which is the x, plus our y, which is kx, to power n, which is 5. So it will give us, we have agreed very well that x is what? X is 3. So where there is x, just replace by 3. Then where there is n, put a 5. Where there is y, put this. So we go, there we go. Which means the other side you have to increase because they said the first 4 terms, but now I've stopped on 3. So let me add just on that. So we shall have here n into n minus 1 to n minus 2. Now this one will drop n minus 3. Then this is now x power n minus 4. Then y power 4 all over our 4 factorial, n plus many others. So shall come and say our 3 power n, which is 5. Then our y, which is k, x power 0. Then plus our n, we have agreed is 5. So you put here 5 into, since we are multiplying, let us put it in the bracket. Our x will know it to power 5. 5, this is 5, minus 1. Then times our y. Our y is kx, but to power 1. All over our 1 factorial, let me put it there. So that one, okay, I will explain down there. Plus, so Mr. Kaziwe, can I rub here?
It is okay.
Okay. So here it will now, we shall go to this one. This one now finished. We shall have now 5 into our 3, which is minus 1. No, it's 5. It's 5, which is n minus 1 into, again, open our x is 3, power 5 minus 2. Then times our y, which is k, x power 2 all over 2 factorial. Then plus our, the next one is 5 into 5 minus 1 into 5 minus 2. Then our 3, our x is 3 to power 5 minus 3. Then y, which is k, x, but to power 3 over our 3 factorial plus our n, which is 5 into n plus 1. Sorry, it's 5 because we have made. Then we have our 5 minus 2, 5 minus 3. And then our 3 to power 5 minus 4. Minus 4. Yes. Which is into our y. Y is x. X power. Let me see. I think we have exceeded because I'm just enjoying writing, but we have exceeded here. Let us erase this one. We remain with this one because our aim is to see whether we shall reach here. So the other side we are exceeded. So if we press our calculator, still we shall set 3 to power 5, which is 243. Then plus, now here we start the algebra, we expand it. So here it will be 3 to power 4, which we had it somewhere here. Here, 5 minus 1, we shall get 4. That is 3 to power 4 now. Then the 5 times 3 to power 4, we shall set 3 to power 4, but still we have the answer, but we can still calculate it, which we have 405 into kx, just power 1. Because I said If it is 1 factorial, it will be 1 times 1. So that one will remain 1. I hope every person can get it. So plus, we simplify now the bracket on top. Then we shall have now 5 times 4, because here we shall have a 4. Then here we shall have a 3 squared. So 5 times 4, which is 20, times 3 to power 3, which is 540 kx but squared all over our 2 times 1, because the 2 factorial. Then if you press on your calculator, you go to press 2, then press your shift, press 2 shift, then you press the other factorial. There is a value, that button of this, that, then there is on top in yellow, written like this. You press there, press 2 shift, then that button there, you will see that if you say 2 factorial, it will give you what? 2. That's why it is 2 times 1. Then plus our 5, we simplify also here. 5 minus 1, that is 4. Times 5 minus that, which is 3. Then times our 3 squared. So it will be 5 times 4 times 3 times 3 but squared, which is 540 into x but cubed over. Now the 3 factorial shall multiply up to 1, which is 3 times 2 times 1 plus many others like that. So if we come, our last step, plus 405 kx, then plus. So this is 2. So here we shall have what? So Mr. Kaziwa, let me also rub here, because our aim is to see this one. So it will be is 2, 4, 3 plus 405 kx plus. So if we press our calculator there, it will be 270, which we have somewhere. S squared, x squared. We have already divided by 2. This 540 divided by 2. Plus our 500, this, the whole of this is 6. So 540 divided by 6, our answer will be 90. 90 into, let me open it, 90, k cubed is x cubed. As many others. I think Mr. Kaziwa, you can see that we can reach here. If we can continue still, we are going to get the same values.
Wow, great, great. Thank you so much. Thank you so much. Yes, that is really very, very good. Why did I tell you that we use the binomial expansion? The reason is the question wanted us to, the question was related to the binomial expansion. Eh? So that's why I wanted you to be within that line such that everyone can follow. But that is a very good explanation and it has really brought it very well. Thank you so much for the wonderful presentation.
Thank you, sir.
Okay. Okay, Mr. Erisa, that was really very good.
Yeah. So, sir, we have another presenter going in for another question.
Okay, that is good.
Good afternoon, everyone.
Yes, good afternoon. Morning.
Uganda Inter-School Virtual A-Level Math Seminar 2023. My name is Wakibia Moses from Senior 6 Science F. Going to take you through question number 38, which says, our question says, we show that cos 3x equal to 4 cos cube x minus 3 cos x. So our question wants us to express this and to get our answer as this one here. So here, if we look at this, this is a double angle. So we are going to expand this. I'll say cos, this one can be written as 2. One can be written as cos 2x plus x. So if we expand this and the double angle, we are going to get cos 2x cos x minus sin 2x sin what? X. So okay, this one is also what? A double angle. So we are going to also expand this one. Okay. So we are going to say cos squared x minus sin squared x. But remember, we have our cos one. So I can bring this side. Minus. Also this one, I'm going to expand it. Thereby I'm going to get 2 sin x cos x. Remember, I have my sin squared, my sin out. So if I enter this one here, I'm going to get it. But before I enter, since our answer wants us to get it, cos, I will make sure that I turn all of this cos. So I'm going to say cos x cos squared x minus this one here. I'm going this one, if we expand this one under, okay, if we expand this one under identities from the, I'm going to get this. So here I will enter this sign here and it will be sin squared x. So this is going to be 2 sin squared x cos x. So if I enter this one here, I'm going to get cos x, but this one is 2 minus, sorry, it must be here, minus, so this one is going to be 1, whereby if I enter this cos here, is affecting all of this, I will get it cos of x, and this one, if I enter, I'm going to get a positive here, and it will be cos x minus this one. If I turn into a cos, I'm going to get it 2. Okay, let me do it here. I'm going to get 2, 1 minus sin, sorry, the cos squared what? X but I have my cos here. I can make this one what? Okay. This cos here is multiplying all of this. So let me do it. Cos x, but this one is affecting it, this one here. So when this one, if I add this and this, I'm going to get it 2 minus cos x minus. So here I can now enter my what? My cos. Then I'm going to get 2 cos x. If I enter this negative, it is going to be a positive, which is cos cube x. So if I get my cos, but here I have a 2. So this one's going, this 2 is affecting the whole of this bracket here. So I must include it. So if I get this 2, I add it to this one, I'm going to get it 4 cos cube x. And if I get this minus cos, I subtract it, 2 cos, I will get cos, I get 3 cos x. Let's prove. Let's prove. So this was our equation from question 38. So is there any question from what I have done?
Okay, the question is, kindly, can you write for us the general expansion of maybe cos A plus B, and then you show us how that expression looks like? Because you did it well here, but some students may get confused how it came about.
Okay. Okay. So
you can write it as side work, no problem.
Okay. So if we get it is if we get sin squared x plus cos squared x, this one will give me 1. So I think this is our identity where we generated. Okay, where we generated this, where we turn this one. Okay, here, this cos, this sign here, if you want to get it, cos squared x, I will say sin squared x is the same as 1 minus cos squared x. Okay. This is where I generated my 1 minus cos squared x. Sir, is it done or?
No, I wanted you now. Can you write cos? Right, cos A plus B.
Cos
open brackets A plus B. Write for us that expansion.
Okay. If we expand this one here, we are going to get cos of A, cos of B minus sin A sin B. I think this now our general expansion, if we expand this one.
Okay, now relate it to cos 2x plus x.
Okay, I relate it with cos 2x plus x, whereby I my cos 2x plus x, I will say this one will be my a and this one will be my b. So if I get this and I put here, I will generate will generate this answer here.
Okay. Yes. Okay. Now that is now. No, now it is clear. It is clear because I know some people might have some, they would have gotten some questions of how you got that. That is okay now. We can proceed.
Okay, thank you, sir. So our question B is saying, our question B says, we show that they have said hence show 5/6 from 0 to 5/6. This is 4 cos cube x plus 2 x to x. This one is equal to this over. So if we look at our expression we are given the question, we are going to say, okay, let me here. I will say cos, but I cos I4 cos cube x is the same as cos 3x plus 3 cos x. Since we have expanded our expression here, and we have got our answer. So we are to, okay, since this one is given in our first question, and we have expanded it, get our answer, I'm going to rate. So now here, I'm going to say integral over 6, the same as this 4 here now is going to represent all of this. This is cos 3x plus 3 cos x plus 2 cos x with respect to x. So if I get this and add to this one, I'm going to get the integral. So we cos 3x plus 5 cos x, but with respect to x. So when we are writing this, must make sure that we put in our limits and this brackets, because we are doing all of this one, all of our expression here, we are integrating it with respect to x. So if I integrate, cos, I will get the negative, I'll get sine 3x times 3 plus 5. If I integrate cos, I'm going to get the the sine of x. But don't forget our limit. This 5/6 this is 0. So if I substitute my limits, I'm going to get sine 3 times 5 over 6. This is multiplication times 1 over 3. But this 1 over 3, I can bring it in plus 5 sine my x will be, this is 5 over 6. All of this, we are subtracting. Okay, let me expand it because the space might be small. So this is 1 over 3 sine 3 times pi over 6 plus sine. Okay, there is a 5 here. Sine pi over 6. All of this one we are subtracting. 1 over 3 sine 0 times 3 times 0 plus 5 sine. This is 3. Okay, this is sine 0. So, but sine, but 5 is the same as what? 180. Whereby I'm going to get 1 over 3 sine 3 times 180 over 6 plus 5 sine 180 over 6. This is subtracting, but this one we are going to get what? 0. If we subtract this, sign of 0 is 0. So all of this part is going to be 0. So here, if I get 3 sine so if I get 180, I multiply by 3, divide by 60, I'm going to get the sine 90. By my sine 90 is the same as what? The same as 1. Whereby I'm going to multiply this by 1 plus my sine 6, sine 180. So I'm going to get it 5 times this one. My sine of 0.5 of 30, I'm going to get it 0.5, which is a half. So I will multiply here by what? By a half. Whereby if I get 1 over 3 plus this now 5 over 2. So here I'm going to get my LCM, which is 6. So if I get 6, I divide by this, I'll get 2. 2 I multiply by 1, I will get it 2. So if here I get this, this 6 I divide by 2, I will get 3. 3 times 5, I will get what? 15. So if I get the 2 plus 15, I will get it 17 over 6. as required. I think that was what they required in our question. Maybe if there is any question.
It is really very clear. It is really very clear. But I want you to avoid writing 2 equal sign on one line.
Okay.
Like in your conclusion, you can put that, you can remove it and put that thing down.
Okay. So here I'm going to get it. My LCM, which was 6. If I divide this, I'll get 2 plus 6. This is it, 15. So if I get this plus this, I'm going to get 17 over 6 as required.
Wow, perfect, perfect. Can you tell us what you understand by the word hence? Whenever they use the word hence in the question, what does the examiner want?
Okay. When they say hence, they want us to begin from where we have stopped.
Okay, perfect, perfect. Thank you so much for that wonderful presentation. It has been really very good, and I'm very sure people have enjoyed it. Thank you so much.
Welcome, sir.
Yeah, then sir, there we also have another representative.
Okay.
Yeah, taking that to another question.
Okay. And you, when are you coming on board?
After him, in fact, after him.
Okay, okay.
Good afternoon to everybody who is part of this session. My name is Mbale SS from Senior 6 Science specifically. I'm a student of Mbale SS, and I'm going to present question number 35, and it's from analysis, that is differentiation and integration. So without wasting any time, I'm going to start with the part A. And part A, we have been given our y is the same as upper code of x, and they want us to prove or to show that y is x is the same as negative 1 over x squared plus 1. So this question is from differentiation, and according to me, I see that there's no way I'm going to integrate to differentiate this question. Only if I take both this side, that's when I can ease my life. That is I can write it like this. What y is the same as x. So if what y is the same as x, differentiate both, it can be hard on my side. So I can make it simpler for me to ease my life. I can say code is the same as 1 out of tan, or it's the reciprocal of tan. So I'll say it's 1 over tan of y the same as x. So if I rearrange, I will get x tan y equals to 1. So from there I can differentiate. I can get the first derivative, and I think appropriately I can use product formula, and it says I can hold x and I differentiate the y. And differentiating the y,
I first of all have to differentiate the angle before coming to the trigonometric function. So my y, if I differentiate it with respect to x, it gives me dy dx. Then differentiate the trig function, it gives me sec squared y. Then plus, I hold now the tan y. So this is tan y. I differentiate x, it gives me 1. If I differentiate a constant, do I get a 0? So from there, if I look at my show, it is dy dx is the subject. So I aim at making dy the subject before doing any other thing. So my x y dx sec squared y will give me negative y. From here, I can make y x subject by dividing through by x 6 squared y. So my dy dx will be the same as negative tan of y over x 6 squared y. But now, from there, indeed we have made our dy dx the subject. But now, in our show, we are not having tan y anywhere or sec squared y anywhere. So I will remember that from this step here, my tan y is the same as 1 over x. So if it is 1 over, if my tan y is the same as 1 over x, it means that at this point here, using the relationship, sec squared y is the same as 1 plus tan squared y. I can substitute this here, then I substitute it for tan y. That is my dy dx will be the same as negative tan of y over x out 1 plus tan squared y. So from there, I'm free to substitute my dy dx is the same as my negative tan y is the same as 1 over x. Then I substitute x into 1 plus my tan y this time round is squared. So I make sure when I substitute, I don't forget square. So I open to make it look like my show. I'll say it's now x into 1 plus 1 over x squared. So from there, I'm free to enter the x inside and see what next. So my dy dx will be the same as negative 1 over x divided by x plus 1 over x. When x is inside, it will be up. So by observation, we get 1x to reduce with the what? 1x down. So we shall remain with something of that kind. And from there I can say my dy dx will not be the same as negative 1 over x divided by, here we know that you can get the LCM, and the LCM there, I think it's x. I'll write my LCM there. Then x divided by 1, I'll get x times x squared plus x divided by x, I get 1 times 1, get a 1. So I have something in simple terms like that. So my dy dx is the same as negative 1 over x So this time around, I can say, let me multiply. And to multiply, I'll make sure I multiply with the reciprocal of this. So I'll get x over x. I'll get x over x squared plus 1. X and x reduces. And I will have my final answer looking like the one they told me to show. So that is it. If there is any question, then you can ask, sir.
Okay, it is very clear. It is actually very, very clear. I want you to take another peek. I want to take another peek. Kindly, there is something you are writing there. Tan y is equal to 1 out of x. But it is okay. It is fine. Okay, thank you. Let's go to the second part.
So my next part, number 35, part B, is from integration. And they've said express this function they have given us in terms of partial fractions. So when we are creating in terms of partial fractions, appropriately we expect the next question to be integrated. And we shall see when we reach there. So I'm going to express it in fractions. I don't know, I can write here. So I've been given a function which looks like this. This is now my question. 35 part A. 35 part B. Here is the x squared minus 10x then minus 9 divided by 2x plus 3 into x squared plus 1. So that is our question we're having at hand, and they're saying we express it in terms of what? Partial fractions. So in terms of partial fractions, I think they just want us to reverse this question. How was it looking initially? And to do that, I think first of all, I can say for this one here, to break it, I will say this one will be the same as A over 1 of the denominator. This one, because it cannot be factorized anymore. So I just say A over that. If I need A to be part of the letters I'm using in my expression. So for the second one, it is the sum of complex to factorize it completely. So what I will do, I will make sure I also look for something related to that. By saying I'll put bx plus c divided by x squared plus 1. I'm saying I'm putting bx plus c over this because the x squared plus 1 cannot be expanded any further. So it means that that polynomial there, it is complex. So I'll look for this solution, make sure that I express my numerator to be in linear form. That's when I can be able to get my partial fractions. So from there, I can say my x squared plus 10x minus 9 over 2x plus 3 into x squared plus 1. The same as A into x squared plus 1. If I'm to get the LCM here, the LCM is going to be 2x plus 3, then x squared plus 1. Then I get this LCM here. I divide by this. I'm very sure I remain with this denominator here. So I multiply with the A. That's what you are seeing there. Then I say this LCM of mine, if I get it and divide by this term here, for that denominator, I remain with this. And that's what I remain with, I multiply with everything, which is the numerator. So I will say this is bx plus c, then I multiply with 2x plus 3. And I put it in the bracket to show that the whole of this is multiplying that bracket. So from there, because I see now my denominator, this side is the same as the one this side. So even the numerator, it has to be equal. So obviously now, I isolate that one and equate into x squared plus 1. Then plus bx plus c x plus d. So I'm having something of that sort. I'm now going to look for ways of the easiest way of getting one of the unknowns, and I'm having 3. So what I'll do, I can look around and see how will I eliminate. And the easiest way is now to make sure this bracket is a 0. If I make this bracket a 0, I think this part will be eliminated, and this one can give me easily this one, the A. But here I'm having 2 unknowns, so I can say when my x is the same as -3/2, I have chosen this one because I want to substitute in this x such that the 2 will cancel the 2 and the -3 will make this one, will neutralize this one to give me a 0. So from there, I am free to substitute everywhere. I can say now, my 6, I'm multiplying it with -3/2. Then I'm substituting for x, -10 into -3/2, then -9, giving me a into -3/2, but it's squared, plus 1, then plus bx plus c, but I'm multiplying it with 2 into -3/3. So, as I said, this one will cancel with this, and this one now becomes a 0, meaning that bracket, even if I do away with it, I have no time. This one now, it will be now 6 over, it will be 6 into this one will be 9. When you square a negative, you get a positive. So here I'll have a 4 minus. Now, because I'm having a minus out and a minus inside, I think it will be a positive. But again, the 2 and that 5 can still reduce. So I can say I'm having 5 times 3 minus 9, giving me, the same thing applies this side, shall have a positive 9 over, no longer 2, but it's a 4, plus, or for simplicity, you can leave the A out still, say 9 over 4 plus 1. And I simplify. Side here I'm having the I'm having 19.5 this side, 19.5. I think the same as there, I think. Yeah, I think I'll have 13 over 4 A. Then I can multiply this one, the 4. If I cross multiply 4, multiply this, and I have 13A this side being the same as 4 times 19.5. So 19.5 times the 4 gives me 78. That's it. 78. Now, get my A. I'll say 78 divided by 13. Divided by 13 gives me 6. If I'm having my A at 6, I can look for now ways of eliminating one of these ones. If I eliminate one, it means that I will get the other, and after getting the other, then life will be very easy. So to eliminate this one having the x, I have to eliminate the b because it's having x. So the only thing is to just make the x to be a 0. And I will say, now I consider a solution when my x is the same as what? 0. When my x equals to 0, I substitute there 6, 0 squared plus minus 10, 0, then minus the 9 gives me a into a 0 squared plus 1. Then plus my b, I'm multiplying it is a 0 plus c. Then I multiply with a 3. Here, this is all 0 equals to, this is my a. This is 0. I have plus 3c. This is positive. Remember, a, I have it. Negative 9 equals to my a, which is 6 plus bc. This one comes this side. It's going to be negative still. And the answer is 15. But negative 15, because when a 6 crosses the equal sign, it will be when a 6 crosses this equal sign, come this side, it will be negative 6. Then when you add to this, it means that it gives you negative 15 equals to 3c. Meaning, this indicates that my c is the same as 15 divided by a 3 gives me a 5, but negative. I've gone well. Then, if I have already C, I have A, means that my B will now be easy to get when I just say any value I'll put in, which is simpler for me. I can put 1. And if I put 1, 1 is very easy. I will say when my x is the same as 1. So when my x equals to 1, I'll substitute it here. So I'll have 6 multiplied by 1 minus 10 times 1 minus 9 equals to, yes, going to be also 1 squared plus 1. That is a into 1 squared plus 1. Then plus a b times the 1, no, it will be a 1 plus c times 2 times the 1 plus this. That is a 5. So here, I'm having my 6 minus 10, then again minus 9 to be negative 13. Sorry, this part is negative 13 already, equals to the A. The A, I know it is what? Yes. Times this is the 2. Then plus 5 into this plus C. And the C is negative 5. Negative 5. Yes. So this is now 12. The 12 when it comes this side, I think it will be a negative 25. Negative 25 will be the same as 5 into 3 minus 5. I'm free to divide by 5. Beside this, I'll have my 3 minus 5 the same as negative 5. Negative 5. So my B will now be negative 5 plus 5. Let's give my B as 0. So if it gives my B as 0, how I'll express it? Now say I6 x squared over 2x plus 3 minus 10 x minus 9 plus 1. Gives me, I got it as 6. Now 6 over x plus 3. Then plus, maybe saying it is a 0. So just x, which is a negative 5 over x squared plus 1. So that's told me to express it in partial fractions, and I think that's what they required. If I have not missed somewhere. Is there any question?
It's so far so good. So good. I'm saying it is good. It is good. We can continue.
Okay, sir. So from there, this is part B. This part B. I go to part C, number 35. Part C. They are telling to integrate. They are saying yes. Find the integral of this, and they want hence as my friend said. Hence means to continue from where I stopped. Meaning by all means I have to get the answer. So I will say integral of x squared minus 10x minus 9 divided by x squared plus 1. With respect to x, I can also write it in form of I can also write it in form of this, meaning I'm also going to integrate what I got. Integral 6 over x plus 3. Then plus, I mean minus
5 over 1. With respect to x. And I have to put it in brackets because it is one value. I cannot separate it unless I am looking for another way. But to show that it's under the same integral sign, then I have to put brackets. So I'll continue with this one here. I'm saying this one is the same as integral of a 6 over x plus 3 respect to x minus integral of 5 x squared plus 1 respect to x. So this part here is easier to be integrated, but this one is somehow. So for this one, we start the derivative. I can say it's the same as for the upper part. I can just say, but
Mr. Kaziba, I want to switch the phone. So
Okay.
maybe you help me send details on my email.
I do what?
For the meeting. I do what? Send those details for the meeting on my email. This one has shut down. I can't take them.
Oh. Okay. So can we first pause, or we wait for him to finish?
Okay.
Mr. Erisa, I have sent.
Can start.
so we are doing somewhere, and that is the integration from here. I had got my partial fraction, so I was trying to compare this and this, and my resolution was this and this. So I now separate them in order for me to integrate easily. So from here, I was trying to say that the integral of 6 x plus 3 respect to x. I can also write it that 3 times 2. Or I can say 3 into 2 over 2x plus 3 respect to x. Then when I look, I see that when I differentiate down, I get what is up. When I differentiate this one obviously will be a 0, but this one will be 2. And the 2 I'm having it up. It means that it's now down. So that one is the same as 3 of 2x plus 3, then plus a constant of integration. That is for this part here. Then for this part, I can take for integral of 5 x squared plus 1 with respect to x. This one, I think I will say let x be, and let x be the same as tan u. Right, that when I differentiate, I'll come up with this dx here, the one I'll substitute in my function, and I'll say now my dx is the same as, I start with the angle gives me du, then you check the big function gives me sec squared u. So to I can rearrange it by saying
my dx is the same as sec squared u. Now I come back to my function and substitute. So I would say this integral of 5 over, when I said my x equals to tan u, means that x squared is the same as tan squared u. So there I quickly substitute u, then plus 1. Then I multiply by my dx, and dx is sec squared u, just to u. That's what we are having. But we see that there is some relationship between sec and tan. So there I can just say, but my sec squared u is the same as tan squared u plus 1. And if I see that, I just make a conclusion that this part here is also sec squared u. Without wasting any time, I can just substitute and say my integral of 5 divided by all of this part is now sec squared u, and sec squared u with respect to u. Then the sec squared u and sec squared u reduce out, I remain with integral of 5 respect to u. An integral of 5 respect to u, I think, gives me 5u plus the constant of integration. But now, from somewhere here, I said my x is the same as tan u. It means that I can say from here, my u is the same as tan of x. So, to make the work meaningful, I can substitute for u. And I will say this is therefore the same as 5 tan of x plus c. But this is for only this part. And for this part, it is here. So I am combining them. First, the one for this part. I said, therefore, integral.
Hello, guys. I'm a student.
Mr. Erisa?
I have it here. So I will say the same of 2x plus 3. Then I will add this part here, the minus. So I put minus.
Не знайте, я піду. Ні.
So I will say minus the integral of this part here. And this part here from all of this, we derive and we reach somewhere here. Means that this is the
Nigger.
Just add here of x plus c. So, because I was not given limits, I retain my constant. But if I was given limits, then I have to substitute and get the final answer. And that's what I've managed to do. My question ends there. Unless there's a question, I am finished.
Okay, thank you so much. Thank you so much for that wonderful presentation. It has been very elaborative and we have been really following very well. Thank you so much, gentlemen. That is very right. And please let's keep on practicing.
Thank you, sir.
Okay.
Yeah. Okay, so I was supposed to be the next, but I have my colleague who is coming before I come, like where you are expected.
Okay.
Yeah,
It's fine.
Number, then I come.
Okay.
Because I'm just going at this one here. This one turning like a yes. Wakida.
You're going to focus the camera very well because it is not so clear now.
It's not clear.
Good afternoon.
Yes. Good afternoon.
Good afternoon to all the listeners. You're welcome, and thank you very much for welcoming me to the platform. I'm so grateful at this time, and thank you very much for all the contributions, because we are learning so much and benefiting from this program. And my name is Shadrach, and I'm going through this time. I'm going through a paper 2 question, and it is coming from question number 73, and it is going to come from numerical analysis. So it is question number 73. Question number 73. Question A. It is asking us to show that the iterative formula based on Newton-Raphson formula for finding the root of the equation x equals to the 6th root of capital N. They want us to show that the 6th root using the Newton-Raphson method is given by xn plus 1 equals to 5/6 into x subscript n plus capital N over 5x subscript n power 5. They want us to use the NRIM formula. NRIM in full is Newton-Raphson method to find the 6th root of n, and we have to show that it is given by this. So we are going to begin, but first of all, I want to quote the NRIM formula, which is nx subscript n plus 1 equals to x subscript n minus f of x over f, the first derivative of the function in x. This means that we have differentiated the function of x, and this is the NRIM formula. So let's begin answering our question. They have given us x equals to the 6th root of n. And for this, we can also write this as n power 1/6. So this will give us, want to remove this one power 1/6, and therefore we are going to power all the left hand side and the right hand side. We are going to power every term to power 6. And therefore, if I power every term to power 6, and also this one to power 6, I've treated the both sides equally. So this one will give us 6x power 6 is equals to n. So when a number which is powered to another number, we have to multiply the what? The powers. So if we multiply 1/6 times 6, we are going to get power 1. and therefore n is going to remain without a power or raised to power 1. So x power 6 equals to n raised to power 1. A number raised to power 1 is that number. So giving us x to power 6 equals to n. So I have to bring this n this side so that I generate an equation, which is x power 6 minus n equals to 0. So at this time, I have to satisfy the NRIM formula by going through this procedure. I let my f of x be x power 6 minus n. X power 6 minus capital N. And also, after this, from the formula, we are having an element of the first derivative of the function in x, and therefore I have to get it. This is how we write the first derivative of the function x, and therefore we differentiate the function of x, which is like this, and also differentiate the right-hand side, which is 6x power 5. How did I get 6x power 5? When you were differentiating this function x power 6, this is how we do. We drop the power, and then the number, we reduce the power by 1. 6 minus 1, which is 6x power 5. So generally, I can write this as n power, this is x, n minus 1. This is how we have come to this one. So this one, our side work in differentiation. So this is applied mathematics. We apply what? The knowledge of paper 1 here. And this n has no coefficient of x, and therefore it is a constant. When we differentiate a constant, of course, we get 0. So this one remains like this. And therefore, but from our formula, we have x with the subscripts. So to fulfill the condition for NRIM, x has to be with the subscript. So we convert it. So I'm putting this line to mean to transform to satisfy this equation with x with subscripts. So this one is going to transform into f of x subscript n equals to x subscript n power 6 minus n. And this one also is going to transform into f, the first derivative of the function x subscript n equals to 6x raised to power n. But of course, it is to the subscripts. So we come back. We have satisfied all what we have seen here in the NRM formula, and therefore we can apply it in the NRM formula, which is now from the NRM formula, which states that x subscript n plus 1 equals to x subscript n minus f of x subscript n over f, the first derivative of x subscript n. So I'm going to substitute all this inside here. So this one gives us n subscript n plus 1 equals to x subscript n minus, I open my brackets, f of xn we have been given, it's already here, we have calculated it, x subscript n power 6 minus capital N over the first derivative of the function in x subscript n, which is 6x subscript n raised to power 5. Okay. Then after, I have to remove these brackets. You can use, we can solve the brackets first if we follow body mass. Yes, x
subscript n plus 1 equals to x subscript n minus, so I'm going to remove these brackets right here. So it is x subscript n power 6, but this negative has to multiply this to become a positive, plus n. But this is a fraction over 6 x subscript n but raised to power 5. So then after we have to use our algebra. Of course, there is a hidden one here, and therefore we have to find the LCM, so that we put all these ones under the same LCM. This one is, the LCM is 6x subscript n raised to power 5. So when I multiply this by, I divide 6, I divide this by 1, I get this term. And then when I multiply with this, I will get 6xn, but this one is multiplying with this, so it's going to be x subscript n raised to power 6 minus, when this, we divide this to this one, it gives us 1, and 1 times this gives us the same terms, x subscript n raised to power 6 plus n. So I come back. They want us to show that this is this. So what should we do next? We have like terms already here. So we solve. So this gives us x subscript n plus 1 is equals to 6 this minus this, you get 5. Because all of them are of coefficients of x subscript n raised to power 6. So this is 5 x subscript n raised to power 6 plus n over 6 x subscript n raised to power 5. Then I come back and I see what's my proof. What do you want the answer to be? It's like this. And therefore, I begin. The first thing I'm going to factor out 5 over 6 because I have an element of 5 here over 6. But let's go step by step. X subscript n plus 1 is equal to 5. Let me first factor out 5. 5 into, I have x subscript n raised to power 6 plus n. But this n doesn't have 5, and therefore we have to generate a number that when we multiply by 5, we go back to n, and that is 1 over 5. And therefore it is n over 5 over 6 x subscript n raised to power 5. So after here, I can say x subscript n plus 1 equals to, I can also factor out my 6 and leave x subscript n raised to power 5 in the fraction. So this one is going to be 5 over 6 into, this one is x subscript n raised to power 6 plus n over 5, but over x subscript n raised to power 5. Not so. So this one is going to give us, and therefore, when I go back to my answer, they want me to get xn, and I don't see any fraction here, but n is a fraction, and therefore, I'm going to separate this into separate fractions. 5 over 6 into, but of course, these fractions are under the same LCM. This is x subscript n raised to power 6 over x subscript n raised to power 5 plus n over 5, but over x subscript n raised to power 5. So what do we get here? This is 5 over 6 into, when you divide a number raised to a higher power by 1 divided by a number less by 1, of course, the more powers will cancel. I mean, the less powers will cancel out. And therefore, we are going to remain with x subscript n raised to power 1. So right here is x subscript n raised to power 1. So this is power 5 and this is power 6. When we divide the numbers of the same, bases, the same bases but different powers, when you divide them, we subtract the powers. So this is going to be, I want to explain how we got this. These are the same bases. These are the same bases. This is my side work. These are the same bases, and therefore it will be xn. So what we do, we subtract the what? The powers to give us x subtract n raised to power 1 is what I have got here. So we continue. This is x subtract n plus, and then here, what are we going to get here? We have n over 5, but over x subtract n raised to power 5. This one can be written as n over 5 divided by x subtract n raised to power 5. And therefore, it is going to be x over 5. We multiply by the reciprocal of the term, which is 1 over x n raised to power 5. And this is n over x subtract n raised to power 5. This is what we are going to put right here. This is what we get, n over x n raised to power 5, as we have done from our side work. So our x subtract n plus 1 equals to 5 over 6 into x n plus n over x n raised to power 5. But where is our 5? Where is our 5? Our 5 is right here. We forgot to multiply by 5. Our 5 is right here. Our 5 is right here. So we include our 5. We include our 5, which was here. And therefore, we have generated the equation that they wanted, the formula. This is the NRIM formula to justify or satisfy the condition. So we have finished for part A. For part A is done. So if at all, there are some questions right here before I go to part B, they may be asked.
Okay, thank you so much, presenter. I feel it is very, very clear. Yeah, the presentation is very clear. Thank you so much.
You're welcome.
We can proceed.
I think we can continue with the part B, which says, it says that so our part B, Roman 1, it is saying that we draw a flow chart. A flow chart that reads n and the initial approximation x naught, and the initial approximation x naught, it computes and prints the root to 3 decimal places. Then finally, it prints n and the root. So I've written this statement to guide me and you how to do the pie chart, the flow chart. So this is our flow chart. So they want us to draw a flow chart. It reads n and the initial approximation x naught. So the flow chart, we are going to start. We are programming. We are going to start. So when we start, what do we start with? We start with the value, I mean, the initial approximation. This is what we begin with. Of course, to begin, we need the value of n to move with so that we can substitute and know if it is going to give us the real value, the correct answer that they want or not. And of course, we need to move with our n equals to 0. This is the number of iterations that they want, the number of times that we are going to substitute the value of xn so that we get the real correct answer that they want. So this is the number of iterations. Then after there, they are saying that it reads n and the initial approximation. So this is the section for reading. It reads n and the initial approximation x naught. And therefore after there, it computes. So the section for computing, I can write it here, and this is how it looks like. And for computing, of course, when to compute, we need to substitute, or we have to put here our formula so that we can compute. So this one is x subscript n plus 1 equals to our formula 5 over 6 into x subscript n plus n over 5x subscript n but raised to power 5. So this one will enable us to compute. And of course, this one should have arrows to show the direction of movement. We move like this. And after, it prints the roots to 3 decimal places. So when they have given us the 3 decimal places, it is going to help us to get the error. That means the error in the computing should be to 3 decimal places. And our error, which is to 3 decimal places, is 0.0005. Not so. So if this is, how do we get that the error should be to 3 decimal places? Of course, our formula of computing error is it? So our formula of computing to 3 decimal places is a half times 10 power negative n. So where n is the number of decimal places. Please help me with my calculator. I want to calculate these decimal places. So a half times 10 power negative 3. Yes. So it has given me a half times 10 power negative 3. This one gives me 0.0005. And therefore my error bound should be less than or equal to 0.0005. Okay, let's continue. This one is going to take us to, this is a section where we are going to ask ourselves if the error bound is less or equal to 0.0005. So you ask yourself, is the error bound less than or equal to 0.0005? You ask yourself. And how do we get error bound? Error bound The error bound that I'm meaning is the magnitude. I'm putting the error bound because the error should not include a negative in our solution. So it is got from x subscript n plus 1 minus x n. So this is what I substitute here. X subscript n plus 1 minus x n. Is this less or equal to this? If you ask yourself, if the answer you really find is true, then you continue.
Excuse me. Yes, what does n stand for?
N stands for the number of iterations.
The number of
iterations.
Now, when you, did they specify in the question? Let me look at it again.
Yes, it is question number 73B.
73B. Okay. Continue, it's fine.
Okay, thank you. Okay. So you ask yourself, is the error bound less or equal to 0.005? If your answer is yes, you continue working. And they say, if it is yes, then you compute. This is our section for computing. You compute and print. So you print out. You print the roots. You print n and the root. Print n and the root. And the root is x n plus 1. Okay? So after printing, that means you have finished. So you stop. You stop. That is when, if your answer is yes. But if your answer is not satisfied, if your answer is no, that means that you have to again move back. But at this time, your n is you are going to substitute. Your initial answer is going to become your x naught of this time. What I mean is this. Of course, you begin with n, not so. So your n is going to become n plus 1. If it was 0 in the beginning, so it is going to be 0 plus 1. After there, of course, now, also, your answer that you got, such that it didn't give you the error bound, which is less or equal to 0.5, is going to become your initial approximation of the second movement or substitution. It's going to become your xn of this time. And then after there, you compute. And where are we? Here. And after there, you again go through the initial procedures. That means after there, you're going to substitute again the value of n if at all they have given it to you. And then substitute until you get the answer here. And then after there, you print. So that is all what I think our question B is asking. And if there are some questions there, you can ask before we go to question C.
Okay, so far so good. It is clear. It is clear. Yes, thank you. You have elaborated it well. But I want you to tell us, imagine they had used significant figures. Maybe they had said, and prints the roots to 2 significant figures. How would you advise someone to approach such a question? Because remember, at times they may tell you in the question, compute and print the root to 2 significant figure or 3.
Okay. So for the cases of significant figures, for significant figures, if at all you got, if they said to two significant figures, what are significant figures? These are figures, let me say, if I'm given 0.001, how many significant figures can I see there?
One.
I think I can see only one significant figure here.
Yes.
As my significance. So it is a figure which is apart from 0. Maybe if I simplify it, it is a figure apart from 0. If I can simplify it. For the cases of this, what I can say about significant figures right now, it is a figure which is apart from 0. So if they said to two significant figures, that means I can see only one significant figure here. Maybe if they say to two significant figures for our answer, to get our answer, that means the answer that we are going to get, it is going to give us, we have to locate two significant figures apart from a 0 that we don't count as a significant figures, which is next to another 0.
Okay.
I think for now, that is what I can explain.
Okay. Now, what I wanted you to say is, are you seeing your error, which is 0.0005?
Yes.
You obtained it looking at the number of iterations.
Yes.
Now, imagine, because remember you have to base on the number of decimal places and so on. What if it was significant figures and they did not mention decimal places?
Okay. For significant figures, I really don't understand that. If at all there is someone else who can help me in that.
Okay, ask your colleagues there whether we have anyone who can make some elaboration on it. Ask and see whether there is any. But have you made such questions?
No, not yet.
Not yet, because at times they may ignore the word decimal places completely, and they use only the word significant figures. Is there a colleague around who can help?
If there is anyone around who can elaborate about, if at all they did not ask you for decimal places, but they said to 3 or 2 significant figures. If at all they asked that, 2 significant figures, how do you elaborate? How could you come to what should and the error be less or equal to? Which error? How could we find the error?
Perfect. You have understood now that question.
Yes, please.
So let's wait. Is there any?
Not yet.
Not yet.
Yeah.
Okay. Okay. It is okay. Let's first, but I want you to make research on it. And then after you come back and you tell us.
Okay. There's no problem. That's noted.
Okay. Take note of it because it is really very important. Questions at times they're not going to specify, meaning you need to look deep and ask yourself.
Okay. Thank you very much for that.
So take note of it, but I will tell you, but after you making your own research.
Okay, there's no problem.
Okay, continue to part B, the next part.
Okay, thank you. So when we continue to part C, it says that taking.
Okay. Kindly first make a collection. Okay, there, put back in your question the 3 decimal places. Remove the A. Since we are taking a recording, I don't want it to appear. It was just a valid out.
3 decimal places.
Okay.
So they have said, they have asked us, they have said that taking n, capital N as 26 and x naught as 1.5. Perform a dry run for the flow chart. So they want us to perform a dry run for this flow chart. Okay, then we begin. Of course, to perform a dry run, we need to know the value of n. We need to know the value of n. So after knowing the value of n, we shall be able to establish the value of x subscript n. And after there, after finding the value of x subscript n, we shall be able to put into our formula and then compute our root, which is xn plus 1. And after finding x plus 1, we have to know if the error bound is less or equal to 0.0005. So our error bound is here. But from here is when we are going to ask our question. I can design this in this way. I can create this, and then I ask myself, is the error bound less or equal to 0.0005? Question mark. So that's where I'm going to answer myself after a number of dry runs. If they ask you about a dry run, what's a dry run? It's just using the given data to follow what the flow chart and then substitute. That's only about the dry run. Use what you've been given and then substitute until you fail to get the answer using the directions here, as we are going to see. So, for value of n right now, they have given us 0, because even here, n is 0. N is 0. So, but they have given us the value of x naught. So xn for the value of n. So x naught here is x naught. And what is our x naught? Is 1.5 for this time. And after finding, then we are going to read n and x naught. We substitute inside here. So we take our value of n, and this is how it is going to be for inserting. How are we going to find x substitute n plus 1 from our formula over 6 into x subscript n plus n over 5 xn or 5. So we are going to substitute and then calculate 5 over 6 into xn for now is 1.5 plus n, but we have been given n as 26 over 5 into xn, which is 1.5 but power 5. So we get our calculator and input the substitution. This is 5 over 6 into 1.5 plus 26 over 5 into 1.5 power 5. So if I calculate here, I go through the procedures. times 1.5 is going to be 1.25 plus 26 times this times 5 over 6 divided by this, divide by 5 times 1.5, but power raised to power 5. 1.5, but raised to power 5. And this one is going to give me 0.5706. So I'm taking the 5 decimal places so that getting the error should not disturb me. The most correct answer, but which the number of decimal places should be more than those ones of the error bound, such that you get the correct answer. It should be less than the number of decimal places of the error. That's what I mean. So if I add plus 1.25, I get 1.8206.4. So I come and input here. This is 1.8206.4. Then I get the error bound. When I get this, subtract this one, this is what I get, 0.32064. Not so. So then I ask myself, is the error bound less than this one? No, it is more than. So is it? No. And therefore I go. After asking myself, the question is here. What is here? Is this one. So if no, then I come back. N plus 1. I come back. My n becomes n plus 1. So it is 0 plus 1, which is 1. Then after there, this statement is also telling us that the xn that you got right here becomes your xn here. And therefore, this is going to be 1.82064. Then I substitute back inside here, where it was 1.5, but right now it is 1.82064. We continue. Is it? That is over 5. Enter 1.5 plus 26 divided by 5 into this at raised power 5. Now this. So I'm substituting xn plus 1 equals to 5 over 6 into xn. Now, right now, it is 1.82064 plus n, which is 26 over 5 into 1.82064 for 5. So this is what I have to get. There's 5. So let me compute for the bracket before I multiply with this one. 1.8 4 plus 26 over 5 into 1.8 2064 at raised to power 5. Power 5 times 506. This one gives us 1.7337. 1, 2, 3, 4, 5. I've decided to take up to 5 of these small places. This is 1.73379. So I get the error bound. Yes, I get the error bound. And I have to subtract this from this, and it should not give me a negative because I see one is bigger than the other. So whatever comes in, it is to the magnitude, and so does not give us a negative value. This one is now 71279 minus 1.82064. This is 0.08685. So is this less or equal to 0.0005? No. If it is no, I again come back. I add my n by 1. So n plus 1 is 2. So I go back. My xn plus 1 becomes xn. This one becomes this. So again, I substitute this right here. So I just replace this, and here. This is 1.73379. 1.73379. So when we substitute, what do we get? So 1.73379 plus 26 over 5 times 1.73379, but raised to power 5. Here, times 5 over 6. This one gives us 1.72142. 1.72142. So again, I get the error bound is minus 1.73379. This is 0.01237, and this is no. Okay, and then we add one. This one becomes again this 1.72142. We substitute it here. 1.72142. 1.72142. This is 1.72142 plus 26 over plus 26 over 5 times 1.72142 raised to power 5. Raised to power 5. It's going to give us this was it. 1.779. 733 divided by this one is it. This one is 26 divided by 5 into 7 337 9 raised to power 5. Yeah. And so adding these things is giving me difficulty. It's giving me difficulty. I want to turn one step back. Because inserting and then putting back is giving me some sort of difficulty. I have one calculator. Maybe I'll go one step back, and after I will put the formula into the calculator and substitute once. Sir, am I allowed to do that?
Yes, you're allowed.
Thank you. So I want to turn back to some 2 or 1 steps back and then substitute the formula into the calculator. So if I turn 1 step back, I will have with another marker. Right. So I want to turn 1 step back. This is 5xn plus n over, this is it. This was what? 6, 5xn or 5. I think this is the, I have turned some steps back to generate this formula right here. I've entered everything inside here to come back to this. Remember, we were when we were working up to this stage, we had this formula somewhere. We had this formula somewhere. Was it like, yes, it was like this. So I'm going to insert this formula in my calculator so that I don't get difficulty of again inserting these values. And so I put this into the calculator, and this is how I'm going to put into the calculator. The value has been given here. I can either use this power 5. I'm going to use this. Sorry. This is what I'm going to do to my calculator. I insert this formula so that I substitute directly the value of x. And this is how you press. You open brackets, you press 5, then alpha, then you press the closing bracket to put x plus 26. Then after there, I close, divide by 6 times z x, that is alpha, followed by the closing bracket to give me x power 5. Then I press the calculate button where they have put solve. I press it, then it will ask me the value of x, and therefore I'm going to put my value of x 1, 5. Raised to power 5, 5x, that's 26. Yes. And I think this one was raised to power 6. Also, to come back here, because this one is to power 5. This was power 6. This one was raised to power 6. Five x raised to power 6, then plus 10 divided by 6 x raised to power 5. Yeah. This is it. 5 x raised to power 6 plus n, which is 26. Power 6 plus n, which is 26, divided by 6 x raised to power 5. So I calculate my x was 1.5, and it gave us 1.82064, and this was this is the correct answer. I'm substituting this another value 1.82064, 1.733. Yes, this is correct. So we go to this one, 1.729 7214 142. Yes. Then the third one 0.7214 1.72121. The sun is really making the calculator display this 211 and 9. So we get the error bound. We get the error. Please help me with another calculator. I can't remove this now. This is 1.72119 minus 1.72142. Okay. The answer is 0.0000023. So After here, we ask ourselves, is the error bound less or equal to 0.0005? And when we look at this, indeed, it is. So we put here, yes. So if yes, what do? We print n and also the x n. Actually here, perform a dry run for the flow chart. We have finished to perform a dry run. Of course, this is the end process. The end process, that means our real value, our real root for the question, that is x n plus 1 is 1.721. I'll put that to 3 decimal places. So I think that is the root, and we have printed it out. If there is some question, I welcome it. So if at all you want to test if you are correct, then you come back. Now, if you want to know that you're correct, come back to your formula of this. Then this is the 60 root of 26. This is the 60 root of 26. If you put this one in a calculator, will it give you the answer this to 3 decimal places? If at all it is, as let me try it here, the 60th root of 26. Yeah, it has given me 1.72119. So to 3 decimal places, that means we are correct. So this was just to prove if our dry run is successful. So that is it. I think now I can say the 60th root of 26 is 1.721. I hope I am done, sir. Any information, any questions, and supplementations?
Okay, thank you. Can you tell them how you can check whether your answer is correct?
To test if my answer is correct?
Yes.
Okay. So, to test if my answer is correct, I go back to the question that I show, and I have some statement that says finding the root of this equation here. So whatever they want to find, they want to find the 60th root of 26. They want from here 60th root of 26. Not so. So I'll have to say now this one is 26 power 1 over 6. So I can directly press into the calculator to get the 60th root of 1 over 6. So when I press into my calculator, I press the shift button and press the power button. I'm using a calculator, Casio, and it is 991 MS. That is the calculator that I'm using. So the procedures are to find the 60th root. 60th root, I can press this into my calculator. I can press this also into my calculator to give
Your video is off. Your video is off. Mr. Erisa? Mr. Erisa?
So, sir, you asked me how we can prove that our answer is correct. So this is what I was suggesting to prove our answer correct. So we go back to find the 6th root of n, and of which they have given us the value of n. Allow me grab right here, and then so for the Newton-Raphson method, we can do like this. For x, we substitute, have given us, x is equal to 6th root of n, and of which they have given us the value of n as 26. So the 6th root of n is going to be like this, 26. And therefore, I can press this directly into my calculator. If it gives me this answer, exactly this answer to 3 decimal places. So I press into my calculator, I insert. I say 6th root of 26. And it gives me the answer 1.721190306. That means to 3 decimal places, my 6th root is 1.721. So when I'm saying that my 6th root is, that means my x is the 6th root of n. My 6th, from here, my 6th root of n is this one. So my 6th root, so I can as well say my 6th root of n, which is 26, equals to 1.721. This is to 3 decimal places. And I have pressed the 6th root of the value 26 from the calculator. So this is how I pressed. I said that I'm using a calculator 991, and it is Casio. So I press 6. How to attain this on a calculator? I press 6 followed by shift, then the power button. Then after the power button, this one gives me, displays the 6th root of n. So this is followed by the addition signs. I'm meaning followed by. Don't again put addition signs into the calculator. So 6 followed by shift, then power button, then plus the number, which is 26. Then press equals to give you the 6th root of 26. So that's how I press directly into the calculator. That is it, sir.
Thank you so much for the wonderful presentation. It is clear. Let me hope, like in the paper, you don't forget to cross that table of yours. The table, hope in the paper, you do not forget to cross the table. Thank you so much. It is very okay. And always, please don't forget, try to check on your calculator whether your final answer really matches. It might not be, the accuracy must be within the same limit. Okay.
Yeah.
Thank you so much.
You're very welcome. Thank you, sir.
Okay.
Nice time.
Okay, nice time.
Yeah, so I think now it's my turn to come in.
Okay.
Yeah.
You can come, please.
Good afternoon to everyone. My name is Mbale. I'm really glad to be among the lucky presenters. Maybe some information in that, because many of us we are here, we want to present and you've been watching, but I'm really glad to be among you, presenting the school as well. I'm taking you through paper 1, that is question 43. The number is coming in from, and that is part of integration. So I'll begin by working out part A. Then I go to part B. Since the question is having 2 parts. Part A have given us x to exponential power x power 4 dx. So by inspection there, I see that the question is coming in from a function and its derivative. So now, if the function, if the equation, a question, the function and its derivative, the method that I normally use in such questions, I get the power. For this case, it is x power 4, and I equate it to an unknown, maybe u. So I can say u the same as x power 4. From there, I'll differentiate. If I differentiate u, let me put on my 4. If I differentiate u, I'll get u the same as 4 x power 3 dx. So now from there, I aim at making the x the subject. If I make the x the subject, I have the x the same as u over 4 x power 3 or 2. Now from there, I'll punch in. I'll substitute in where by dx, where I can see it in the question. So it is integral of x power 3 exponential. Remember now here I'm going to put in u since I've rated in the whole function. I mean the whole power to me. So I'll use here time of the derivative. I mean time of the x, which is u over 4 x power 3. Now there, I come to realize that I'm having some common elements which can cancel. This is x power 3, can cancel with this. Then there I will just remain with integral of exponential u minus or du. Now I can integrate this. When I integrate this, I just remain with exponential u plus the constant of integration, which is c. But in the question, I'm not seeing anything like u, so I put it, this u just rated. So I put it at the real value that was supposed to be there, which is my x power 4. So this is going to be exponential x 4 plus c. That is what we can get as in our part A. Part A. That is what is required. Then I think you can now shift to part B. Part B does say use substitution t. T is the same as tan x to find integral of 1 over 1 plus sine squared x dx. Now they have given me t to be tan x. Now begin by that very statement by integrating it. So now from t is equal to tan x. I integrate this. If I integrate that, I'll have the t the same as sec. If I integrate tan, I get sec squared x dx. As we made here, we can also make it here. But now for easy substitution, so we can now have the t dx equal to t over sec squared x. But sec squared x alone is the same as 1 plus tan. It is now t over 1 plus tan by squared x. But if I look at here, this statement is telling me that tan, I mean t is the same as tan x, so I can now patch in here, which means my x alone is going to be t over 1 plus t by t squared. This tan is squared here, and now squared by t. This is my x. Now I come here. I'll look at this. How can I call it? Maybe this. Okay, like this side squared x. I can now look for that idea from the double angles. So I can now generate it from this cos x alone is the same as cos squared x minus sine squared x. Now, the reason as why I brought in all this is to get the identity for just sine squared x. So now, implying I must make sine squared x the subject. But to make sine x the subject, I must also maybe simplify this further, which is also the same as 1 minus sine squared x minus again sine squared x. This one is the same as 1 minus 6. All of them are the same, minus 2 sine squared x. Just as this one alone of 2 cos, cos 2x has given me this. So now, as I said at first, I aim at making only sine squared the subject so that I can now get the result. I punch it there. Then I proceed with the calculations. So making sine squared the subject, I'll have 2 sine squared x, the same as 1 minus sine, cos 2x. And reduce here by 2. Then this is affecting everything. Means I'll introduce a half. So now I come to realize my sine squared x is giving me 1 over 2 minus cos 2x. So where there is this, I'm going to use this. Then 1 over 1 plus the half. But this half, maybe I can just write it as I can just write it over 2. I can just write it over 2. Then this one also over 2, which means it is 1 minus cos 2x over 2 times. Now my dx, I multiply here with x, which is my dx is here, which means it is t over 1 plus tan squared. T over 1 plus t squared. Then when I look at this course, I can now introduce the idea of t formula. Now, if I see, I introduce that idea, my cos, no, cos x is the same as 1 minus t squared over 1 plus t squared. Now, if I'm having cos 2x, that one shouldn't bother me, because now they're telling me that t is the same as tan x. If it was maybe here like a half angle, then I can make, maybe they are good to have. Now, since I've just here, my cos 2x is also the same as 1 minus t squared over 1 plus t squared. Then I can also use this very idea. I put it here. It's some information. And I want my equation to be in terms of t, so that I can now eliminate this aspect of 2x. So now I'm having my integral 1 over 1 plus, open brackets, this is 1 minus 1 minus t squared over 1 plus t squared. Then the other thing, I'm dividing it by 2. Then I'm multiplying the derivative with the x, my x to t over 1 plus t squared. Now here, we can simplify this. I think I can begin by simplifying this part by getting the LCM. This is 1. My LCM alone in this part is, remember, this is over 1. So I'm having 1 plus the LCM is 1 plus t squared. So 1 plus t squared, if I divide it with this, then I multiply it with this, I just 1 plus t squared. So this is 1 plus t squared. Then minus all of this divided by this, I think I will take the numerator since I see this and this. Then with 1. But remember this numerator, so when I'm going to relate, I should be very keen on this negative sign, which means I'm going to have 1, which is already negative, and my t squared plus t squared. Only this part, the bracket I should use this. Doing all this to both nodes that I can also prevent chances of failing or despairing. Then I'm dividing the whole thing by 2 times the t over 1 plus t squared. Then I'll not get that, I will still get the LCM. If not, I simplify this part. Because I see some this is 1 over 1 plus this one and this one cancel. Cancel them out. Then this and this will give me 2 plus 2 squared over 1 plus t squared. Then we need with 2, this 2 down minus t over 1 plus t squared. Maybe then there, I'm having this one. Maybe I'm having 1 divided by this. Then the whole of this is also divided by this, which means I'm having 1 under integral 1 divided by 1 plus 2t squared. This part. Then I'm also dividing it over 2. This part which is 1 plus 2 squared. Then I'm also again dividing my 2. Okay, we are following. Oh, you know you cannot. Over this is 1 plus t squared. So I can now do some this is the same of 1. If I put there the primary side means introducing the aspect of C. Now this part alone is going to be 1 plus t squared over 1 plus 2 t squared. Then this 2 alone is the same as 1 over, I mean 2 over 1. So also times, if I do the receipt, it will be 1 over 2. Any times t over 1 plus t squared. So this aspect, I can summarize it in this way. My numerator is 1 plus t squared over. Now this one is plus x times dt over 1 plus. Now, the reason that's why I say that around here, this is a function, and this is, which means I should have an element of function. So you see that this part and this part, they are cancelled. So I can now bring Michael constants. I can see a constant that can do the coefficient. So it's also the same as half into 1 over 1 plus 2t squared. Now, there is I mean, integrating only this part, so I cannot introduce that aspect of the mean. For someone may direct the goal and says, I have to leave of this, but I look at my somewhere square, which means their link will not work, and if I introduce their link, means I will have one more. So now that part to proceed to just integrate this part, I will say that x 2 equal to tan u. This when I depreciate this, I'm adding to the side. Yeah, so I make the other subjects. I'm going to have, I need to use the same as 2 over 6 squared. 6 squared. So I can now multiply 1 over 2 integral 1 over. So this is 1 plus 2. But my 2, I use a here. That is the same as just my 2t, but remember it's squared, which means squared. Then it times. When I integrate this, I get it. When I differentiate, I remain 4. Productivity, the same as 6 squared. Then from there, I can make my subject, which is 6, which is the 2. 6 squared over 4. Yeah. So now I can now find it there. But now if I put this, I'll have this minus 1 over 1 plus 10. So that will be minus 6 squared over 4. No, cannot have a unity. Cannot have a unity. Which means I have messed up. I want everything to be in terms of. I think I was going one way from the first step. This is if I just look at this part. Squared. From there. Here, I cannot get this mixed, and I put it here because I mean you. But here I'm having it. Means this part not proceeding well. So I look for the way of getting the T. I can punch it here. I get that T. I don't know, maybe there is someone that can read. Maybe I'm not observing it well, that can help me with this part. So I don't know whether we have been following together.
I'm following.
Yeah, I've reached this step whereby I think we have moved on well. We have reached here.
Mm-hmm.
Yes, Master?
Yes, it is okay.
Yeah, then what I was doing, I was just getting the part of 2t to let it return. The reason I'm doing that, when I square, I mean, when I punch it back, I'll have the square. And also, I'm also aiming at seeing that turn and that turn being generated out of the function. But when I did put this, I just get 2 equal to sec squared u. So u. Now there, it means I'm just getting u. And yet, in my expansion, I mean in my formula, I'm integrating, I'm having the t. So the u.
Now, the way you are letting, that 2 must be a square root.
The 2 must be square root.
Yeah.
Okay. I think this is the part that is making me go wrong.
Okay. Now what you do, you first remove that. First remove let 2t. Now you select 2t squared equals 2t squared squared equals
under root.
No, without.
Yes.
Yes, I want to show you how it comes about. 2t squared equals to tan squared u.
Tan squared. Like that.
U. So now when you get a square root on both sides, what do you have?
So when I get the square root, it means I have square root of 2t. Tan.
Okay, now continue.
So from there, I can now differentiate to get 2 the same ones, sec squared u. So I make
now remember this side, you are remaining with root t. You are remaining with, like when you differentiate t, you'll get root 2 dt.
I see that, sir. Thank you. Okay, so yeah, then I can now make it a subject, which means I'm having the t versus sec squared u over u2 and u. Thank you, sir. This is now, I can now find there, which is a half integral 1 over, and this is now the whole of this is tan squared, but we want a 1, so it is 1 plus tan squared u times my dt, which is here, which is sec squared u over root over. Now there, tan plus tan, I mean 1 plus tan u, 1 plus tan squared u is the same as sec. That is a half into 1 over sec squared u times sec squared u over root over 2. Now this and this will cancel. So remember here it is having u. This is u. So this is a half into 1 over root 2. I can also put this coefficient out. Just have 1 over 2 times 1 over root 2 integral, which means I'm having 1 over 2 root 2. So integrate that, I get 2 plus what's the integration. But I'm not supposed to get it in terms of u. I need to get it in terms of x. I was given. So now, from let's say here, I can now get my u. My u from here, from 2t squared, the same as 2 tan squared u. I want to get u, which means now I can now get it from this step, which is simplified. This step is from square root of 2t equal to tan u. I want to get u, which means u alone is the same as after tan of root 2. After tan of root 2 t. Again, my t I was given as tan x, so which means there my u is going to be tan inverse of root 2 tan x. So now I can now bring this u and put it here, which is 1 over 2 root 2 after tan of root 2 tan x plus the constant integration. Yeah, I think this is now our answer in that format. That's what I think. Yeah, sir, maybe any question concerning that?
Okay, so far that is very good. Yes, I'm just following up. There's something I am saying. I want to see how we got this two down. Okay. Just go back a bit. I'm looking at this half, but that is so good. Okay. Yes. Okay. First, go a bit. I'm following up on that too. Okay. Then how it came about, where it came about from there. Okay, you move a step behind, a step. Now I want from this side where we have cos.
This side.
I want full up from that point to...
Yeah.
Okay, but that is very good. Yeah. Thank you so much.
Okay. I really also appreciate you for the hope that you've also learned this thing, because now I just came in abruptly, wasn't prepared for the question. But next time I'll give myself enough.
No, but you have presented so well. You have presented so well.
It's my pleasure.
Thank you so
really
much.
Appreciate it.
Okay, that was a good presentation. By the way, that number, I think you have not, it's not an easy one. It requires you to prepare, but you have really smashed the number very well. Thank you so much.
Welcome, sir.
So, sir, here we have another presenter.
How many presenters are remaining with?
Remaining with one only.
Okay. Are you the last one?
Yeah, there is this one, and then me behind the camera, you will come for the last number, but we shall share it.
Okay, fine. Okay, we can start.
Okay, sir. Good evening to everyone. My name is Alfred Okiring, student of Mbale SS, doing BCM/ICT. I'm here to handle a question on geometry and specifically in conics. This is number 32. Question 32 says, find the equation of the tangent to the parabola. Given the parabola as y squared is equal to 4ax at the point P is at squared 2at. So since they want us to find the equation of the tangent, we're supposed to get, first of all, supposed to get the gradient of the tangent of the parabola at any point. So to get the gradient of the parabola, we differentiate the equation of the parabola. So we shall have ddx of y squared equals ddx of 4ax. So when we differentiate this, we shall have 2y dx equals, when we differentiate this, we shall have 4a. So we shall have here dy dx equals to 4a over 2y. This is the gradient of the curve at any point. But since they want us to get the equation of the tangent, the parabola at this point, so where there is y, we shall substitute in the value of y. Because since we are given the coordinate of point P, this coordinate is for x, then this coordinate is for y. So we shall then substitute into this to get the gradient at that point. So at point P, 80 squared 280. Y is 280. So we shall get the gradient 4a out of, where there is y, we shall put 280. So this is 2 into 280. So we simplify this. Y dx the same as 4a out of
for 18. So the gradient at that point will now be y dx is this, will cancel with this. So we shall remain with 1 over 2. So since this is the gradient of our curve at this point, so we shall, using the general equation of the line, y is equals to mx plus c. At this point, y is 280. We have m, which is this 1 over t. Then x is 80 squared. So we need to get the value of c. So we shall substitute 280 is equals to, our gradient is 1 over t into 80 squared plus c. So we're supposed to get the value of c. So we shall have 280 is equals to 80 squared over t plus c. So simply we shall have 280 is equals to, this t will cancel with 1t, so 80 will remain to power 1. So this is 80. It remains as 80 plus c. So to get the value of c, c will now be equal to 280 minus 80. So c will be 80.
Okay, excuse me.
Yes, sir.
Excuse me.
Yes,
okay.
please.
I kindly request you the previous discuss and tell him he's going to come back after your presentation. Eh?
Okay, sir.
Okay, let's continue.
So since we have gotten the value of c here, so using our general equation of a line, this, we now have the, where there is c, we shall substitute this value. Where there is m is the gradient. The gradient we got as 1 over t. So we shall now have, therefore, our equation of the tangent is equals to, our gradient is 1 over t x plus 80. So this is our equation of the tangent at that point. So the equation continues and says, and write down the equation of the tangent at point Q. We're also given another point. Point Q. We're given as 9a negative 6a. So since we have the general equation, I mean the general gradient of the curve at any point, which is given as dy, x is equals to 4a over 2y, where we got from this point here. So where there is y still, we shall put in the coordinate of y. So dy dx is the same as 4a out of 2 into negative 6a. So dy dx here will be 4a out of, this is now negative 12. This is negative 12a. So we simplify this. Y dx will give us, by this one, this shall remain with 3. So the gradient will be negative 1 over 3. So still using our general equation of the line. No, a tangent is always a line. So using our general equation, y is equal to mx plus c, where this is the gradient which we have just gotten. X, we just use the coordinates that have been given, and then also the value of y. So we still get the value of c. So y is 6a, negative 6a is equals to, our gradient is negative 1 over 3, and x is 9a plus c. We simplify this in order to get the value of c. Negative 6a is equals to negative 9a over 3 plus c. So we now get the value of C. So I have negative 6a is equals to, this 3 reduces this. So now have negative 3a plus C. So to get the value of C, so C will be equals to negative 6a plus 3. When this negative 3a crosses, unequal sign becomes negative. So we have negative 3a. So our C is equals to negative 3a. So then we go back and look at our general equation of the line. So since we have got now the value of C, now substitute for the value of C and the value of the gradient. So you'll have y is equals to m. M is a third. We calculate it here. So this is negative 1 over 3 x plus c. But since plus c is now negative value, so we'll have minus 3x. So this is the equation of the tangent to the parabola at point Q. So that was where part A was ending. So go in for part B. Part B goes given an equation of an ellipse. So any comment about this in addition, subtraction?
Let's continue.
Okay. So we're going in for part B. So part B, we're given an equation of an ellipse as x squared over 8 plus y squared over 6. Yes, over 6 is equals to 1. So from and 1, they want us to get the coordinates of the foci. And for us to get the equations of the foci, not the equations of the foci are always given by this positive or minus AE 0. So we're supposed to get the value of A and the value of E. This A is the centricity. So to get A, we compare with the general equation of an ellipse, which can be given as x squared over a squared plus y squared over b squared is equals to 1. So we just compare. Since we are given x squared over 8, and the general equation has x squared over a squared, and we want A. So here, if we compare as 8, so A is the same as root of 8. So I've gotten the value of A. So we also need to get the value of the E, which is the centricity. And to get the centricity, we have to use this formula. B squared is equals to A squared into 1 minus E squared. And still, well, we just compare the general equation and the equation that is given. So from this equation, our P squared is 6, our A squared is 8, and we're looking for a centricity. So B squared, we just substitute 6 is equals to A is 8. A squared is 8 into 1 minus E squared. So since we're looking for this, so divide both sides by 8. So 6 over 8 is equals to 1 minus E squared. So bring this 6 over 8 minus 1 is equals to negative E squared. Shall simplify this. Have 6 over 8 minus 1. It is negative a quarter. So our negative e squared is equal to negative a quarter. So since we have a negative and a negative, divide both sides by negative 1. We shall remain with e squared is equal to 1 over a quarter. So then we get, since we have e squared, but we want just e. So we shall get the square root of it on both sides. So we shall have e squared under square root, so is equals to 1 over 4, all under square root. So we shall remain with e is equals to the square root of 1 is 1, and the square root of 4 is 2. So this is our eccentricity. So go back and conclude that therefore the coordinates of the foci are plus or minus. A was 8, the root of 8. Root of 8 times eccentricity, which is a half, times a half, 0. So we simplify this. So the foci will be plus or minus root 8 over 2. So these are the coordinates of the foci of our ellipse. So this was Roman 1 of part B, and Roman 2 of part B. They want us to find the length of the lattice rectangle. And if we have, take an example, we have our ellipse. Because this is a horizontal ellipse. When we have this, and we have the focus is here. So at the focus, we have since on the positive side, we can have AE 0. I want us to find the length of the lattice rectangle. The lattice rectangle is that chord that passes through focus. So this is the lattice rectangle. So they want us to get the distance from here to here. But for us to get the distance, we know at this point, the coordinate at this point is AEY. So our main aim is to first get the value of y. Now, if we get the value of y, it's the same value that is from here to here. The same value, that length is the same as this. So if we get the length of y, just multiply times 2, we shall have gotten the length of the lattice rectangle. So to get this, our ellipse is given as x squared over 8 plus y squared over 6 is equals to 1. So at this coordinate, we have x. This is our x and this is our y. So we need to get the value of y. So since our x is AE, so but AE, we can find it out. We got using our focus, the equation of the coordinates of our focus. We got the value of n and the value of e. So x is a was root 8 times a half, which was our eccentricity, the same as root 8 over 2. So we shall now substitute this value into our equation of the ellipse to get the value of y. So we shall have root 8 over 2 all squared over 8 plus y squared over 6 is equals to 1. So we simplify this, we shall have 8 out of 4. When you square a root of a number, you get that number. shall get 8 over 4. All out of 8 plus y squared over 6 is equals to 1. So this is the same as 8 over 4. 8 over 4 times out the reciprocal of the denominator. This is 1 over 8 plus y squared over 6 is equals to 1. So this and this will cancel. So we shall have 1 over 4 plus y squared over 6 is equals to 1. So I'll take this the other side. I'll have y squared over 6 is equals to 1 minus a quarter. Y squared is equals to, y squared over 6 is equals to 1 minus a quarter, 3 quarters. 3 quarters. So here we shall have y squared. Multiply both sides by 6 because 1 will only get the value of y. So we shall have 3 over 4 times 6. So y squared is equals to this 3 times 6 is 18 over 4. So take the square root on both sides because we just want the value of y. So y alone is equals to root of 18 over 4. So since we have gotten the value of y, but we say that the length of the lattice vector is the same as 2y because 2y because this distance from here is the same as this distance from here. So this and this are the same. These two distances are the same. That's why you just get the value of what the coordinate of y in your plate times 2. So the length, the lattice vector now given us 2y. Where our y is this, we shall now have 2 into root 8 over 2. This 2 and this will cancel. Let's just fit that value there and get the whole value. So root of 18. This is 18. Not 8. So root of 18 I'm getting the value as 4.24 2426 units. That is the length of the lattice vector. I think that was where the question was ending. Any comments? Any additional subtraction?
Thank you so much for the presentation. It was really very nice. Yeah, I think it is really very good. Thank you so much.
You're welcome, sir.
Okay. Let's have the last presenter, then the other gentleman comes back.
Okay, sir. So, sir, the next presenter is doing part A. I'll also come and I do part B and C.
Okay, perfect. It is okay.
Okay, I'm going to do part of number 10.
What's your name?
My name is Ross Emma Edward, and I'm doing part A of number 28. The question is about trigonometry, and they're just saying we simplify some functions. They're saying simplify. They're saying we simplify sin of 105. Over 105. Now just to simplify, and they want the answer is this one. This implies that we have to work until we reach at this point. Now, I'm beginning from this function. I've given us sine of 105 minus sine of negative 15. But when a sine function has an angle, has a negative, it implies that it's the same as a negative sine that very implies that this negative is going to come behind here to make this positive. So sine of 105 sine over cos. Now for a cos of a negative angle is the same as cos of a positive angle. So I think we do not have, if I just write cos just like that. Then now for these two up here, I'm going to use factor formula such that you can have cosine sine is 2 sine the first angle plus 105 plus over then cos 105 over for a cos plus a cos price 105 plus 15 over 2 then a cos 105 minus 15 over 2. Now we realize that these two and these two are cancelled, so we do away with them in the next step. Now, this 105 plus 15 is 120. Which is sine of 120. Sine of 120 over 2. Then a cos, this cos of 90 over 2 over this cos is cos of 120 over 2. Then a cos of 90 over 2. Now we realize that again that this cos and this one is still 4. They are the same, they cancel. Now we remain with sine of 120, this sine of 60 over cos of 60. This is now where we are. Now we are going to use now special angles. From special angles, the sine of 60, the same as root 3 over 2, then a cos of 60 and a half. That means we can just get these special angles and we substitute them, where we shall have root 3 over 2 over half. So this will become root 3 over 2, simplify from root 2 over 1. This and this will be done. And our solution. Yes, sir. Anything from my solution?
Not really. Things are okay. Just because can you show us that triangle where you are obtaining root 3 out of 2? Do you know that triangle? Okay. How you obtain root 3 out of 2?
Yes.
Do you know that triangle? Okay. How you have obtained root 3 out of 2?
So, I have a triangle like this. Then, if it is equilateral, that means we have a 60, then a 60, and a 60. So we can simplify, we can set it out such that this is 30, and this is 30. Now, this one, if all the length, if it is equilateral, that means all the lengths have the same units. So if this was 1, this implies that this is a half, then this one is also a half, and this is 1, this is 1, for them being equilateral. So now we can come and we say cos 60 is given by adjacent of hypotenuse over hypotenuse. Now our adjacent, remember we split it, our adjacent is a half, then the hypotenuse is 1. So this remains just what? A half. Now for sine, remember sine is opposite over adjacent. No. Sine is opposite over hypotenuse. Now, we don't have the opposite. That means we shall use this and this to get the opposite from Pythagoras theorem, whereby we can call this a square a, whereby a squared plus b squared is c squared. Now, this is our a, the one we are looking for, and this is the b, this one, plus a half, but it will be squared, which is equal to c squared. But the c is 1, so we can just put here direct 1, such that we can have a squared is equal to 1 minus this one is a quarter, 1 over 4. So a squared is the same as 4 LCM minus 1 over 4. A squared is this is 3 over 4. A is now root 3 over 2. Now, we have our A, which is the opposite. Then we have the hypotenuse already. That means the sine of 60 is the sine of 60, the opposite is this. Over 2 over 1. Sine of 60 is now 3 over 2. Yes, sir.
No, it is fine. It is fine. Thank you so much.
Yeah, welcome.
Thank
sir.
you so much. Okay. Let's have the next person.
Yes, good afternoon once more. This is Spiru and Wasiboni by the secondary school. I'm also continuing from where my friend has stopped. And I'm doing part B of it. Doing part B of it. So part B is saying that we are given that x part B is saying that we are given that we are x our markers our x is given that tan theta minus the sine theta and y is given by tan theta plus sine theta. So they are saying that we prove that x squared minus y squared is the same as 16x y. So now here, since I have my x and I have my y, they want me to prove that the left hand side is equal to the right hand side. So me, I will consider starting with the left hand side, working out because I have the x and the y. So from my left hand side, which is the same as x squared minus y squared. Now here, simplifying first of all, when I first simplify here, I'm seeing the difference of two squares. So I first of all say, from our general term of a squared minus b squared, which is the same as a plus b into a minus b. So most of our colleagues mistake this thing here with this one here. So this one will never be equal to this one here. I hope every person is aware about that. Because if you try to force to expand this one, you will not come back here. So from the upper one, I will say my x plus y into x minus y. So I will come and I say, but from the given expression.
Kindly focus the camera so well. Focus the camera so well such that we can see.
Mr. Kaziba.
Yes, Mr. Isa.
I wanted to switch this camera to get joined as well. Just allow, I have a device in the waiting room.
Okay, I've admitted.
Okay, so I hope we can continue.
Yes, continue.
Okay, sir. So I was here at this step whereby I got my expression of the difference of two squares. Then now I will come back and I say my x is given up there. So I will say I can get the sum from here and I get also the difference from up there. So I will say I will first of all get the sum of these two, whereby I have done theta minus sine theta, then y is equal to tan theta plus sine theta. So I'm saying that let me first get the sum of these two. And I see what next. So here I will have x plus y is the same as, if I get tan theta plus tan theta, it will be 2 tan theta. Then if I come to negative sin theta plus the sin theta, it will be 0. Hope every person, because the negative plus the positive, the negative will dissolve in the positive. So we shall only remain with what? With the 2 tan theta. Then I can also get my difference here. I can get my difference. Also, I will say from that very expression of tan theta minus sin theta. Then y is it? My tan theta. Then plus sin theta. So I need also the difference of this bracket here. Then I now say my x minus y is the same as, if I get tan minus tan, that is automatically 0. Then if I get negative sin theta minus sin theta, the negative, I'm getting negative sin theta minus sin of theta. There, I hope every person is seeing that we shall get negative what? 2 sin theta. So it will be negative 2 sin theta, implying that I will come back from where I said my left-hand side, which was this. Then we had reached at this step, so it will be, we first write that step so that every person can see. So here I have got the sum as 2 tan theta, and then I have got the difference as negative 2 sin theta. So I will come here and I put, and I say, this is now 4. Okay. You'll excuse me some to prove that this one was a square. Yes, this one was a square. So implying that everything here we shall correct this one. Then if we come here, okay, everything now we are. Yes, so let us substitute our expression here, which is 2 tan theta in brackets times negative 2 sin theta but squared. So this one will become negative 4 tan theta sin theta but squared. So I will have, I can now enter this square. But if not, I can simplify also the bracket, has no problem. Whereby my tan is given by sin theta over cos theta. So in bracket, sin theta over cos theta. Times sin theta. Here squared. So here I will have, let me see. So it will be negative 4 sin squared. Let me leave it because I'm going back where I'm coming from. So let me just say this is the same as 16 positive, because if I square negative 4, it will be 16. Then the tan squared theta sin squared theta. So now I will first of all pause from there. And I come back, because there now the 16 I'm seeing it on the right, because you are moving from the left going to the right. So there the 16 I'm seeing it. Now I need what? My x and y. So I will come back and I say, but if I multiply the two, can I get what I'm seeing here? So let us see. This is our left hand side. So I will say again is the 2 tan theta minus sin theta. Then my y tan theta sin theta. So if I multiply the two, Let us follow and we see. This one is the same as xy is equal to, okay, let me put to the right and I say something. This is the theta minus this times our tan theta plus sine theta. I hope every person is seeing that is the difference of what? Two square, a difference of two squares, yeah? So my xy will be the same as tan squared theta minus sine squared theta. So now there, let me see where to substitute it. Because what I'm having up, I'm having tan squared and sine squared. So I have come very well. So if I can get here, I can express this tan here in terms of sine and cos. Let us first see what I can make a good product there, and I see sine squared theta, cos squared theta, and then minus sine squared theta. So implying that I can get what? The LCM there. So I will have my xy, and then this is the LCM is what? Cos squared theta, and then so our LCM, since it is that one, if I get my LCM divided by this, it will be 1 times that. It will remain sine squared theta. Then minus this here, I will have sine cos squared.
Teacher, these are the camera.
That I use this.
Not clear.
Yes, sir.
Maybe there is a lot of reflection. Reflection about light? Yes, because we are not seeing very clearly.
Okay.
Okay.
Okay, let me try to adjust the mark and I see. I don't know whether I will be allowed to use red because our black, all of them are not right. And the ink, I think, has.
Okay, use red.
Okay, sir. So at this step, I was saying you can get the LCM. Our xy will be the same as our cos squared theta. Then if we get that LCM divided by this, it will be 1. Then now 1 times sine squared will remain as sine squared theta. Then minus our cos squared theta, which is divided by 1, to remain cos squared theta times up. So it will remain sine squared theta cos squared theta. So from there, I can say my xy is the same as I can pull out what? I can pull out this sine squared here. So for every person following, then minus my cos squared theta all over my cos squared theta. So remember, now here we shall use a lot of tricks. Okay, here I'm having already the tan. I'm having tan squared, which is okay. That is what I'm searching. That one I have confirmed it. Now, here, this one minus cos squared. Remember, from our identities, the first identity from queen shall have the sine squared theta plus cos squared theta is 1. Now I want to make this one. I want to express now sine in terms of cos squared. So there I will be forced to make sine squared the subject of the formula. That will be sine squared theta, which is the same as now if as we cross the cos squared, the other side will be a negative, which is minus cos theta, cos squared theta, implying that I will come back in my product. I replace where there is 1 minus cos squared theta, I will put the sine squared theta. And it will be now tan, tan squared theta. Then, so we have agreed that where there is 1 minus cos squared theta, I will put there what? Sine squared theta. So, allow me put that, which is there. Now, from there, we know that we are proving from the left. We have not forgotten that we are proving from the left. So, from our left-hand side, still, we are still having it, our 16 tan squared theta, sine squared theta, squared theta. So, but I have my tan squared theta and sine squared theta. So this one will be the same as my 16 into xy, which is the same as the right hand side. Therefore, it's true. This one is equal to, therefore, conclude by right is equal to 16 because I used the left. So, sir, that was our part B. Is there any question that I can?
No, it is clear. It is clear. Thank you so much.
Welcome, sir. So let us go to the last part there, part C. But what I can emphasize most, sir, maybe this thing here, our friends must take it serious because it normally confuses the A squared minus B squared being the same as B. Because we can prove it and we see that we can get the left-hand side if we try to simplify here, but it will never happen for us to have this to be the same as B plus that minus this one. Because if we try to express to simplify the right, we can't get the left. So that is my interest so much. Yeah. So let us go to part C. Yes. Okay. So part C, they are telling us that if P, capital P, capital Q, and capital R are angles of a triangle, then they want us to prove that our proof is here, small p, but cos squared P capital over 2. This is small p. Then plus our quarter squared into our capital Q over 2. Then plus 1 over R cos squared capital R over 2 is the same as P plus Q squared over 4 PQR. So they are telling us that we proved these ones are given as the what? As the angles of the triangle. They want us to prove like this. So I will start again from the left. I don't know why I use right, but I like so much the left. But I think okay. Let us start from the left, going to the right, and we'll see whether we shall get the right. So from my left hand side, which is equal, I can't get tired of writing this, so I will recopy. And I just copy and I paste it here, my left hand side. Also that one is needed. Yeah, I will copy it that they can see. That is Q over 2 plus 1 over R cos squared capital R over 2. So here, me as I can start now. I can go and I use the cosine rule because I'm seeing cos is dominating. I can't bring in the sine rule because I'm not seeing there the what? The sine, implying that let me use the cosine rule. So from the cosine rule, from the general, let me use A. So if I say, I hope every person that is in the logo book, that formula of the cosine rule, all the formulas are found behind there. So from the general, A squared is the same as B squared plus C squared minus 2A 2 B C. Then this is cos. Okay. So from this, because my interest is only in cos. So I'm going to come back and I relate up there. Because here we have just used the general term. So you allow me and I remove it and I bring the variables used in the question, which is P, Q, and R. So if it is so, I will bring and I say, I will start with the P. From P squared is equal to my Q squared plus R squared minus 2 P R cos capital P. Even. So I only need, I will now search for this P over 2, the half angle. Now I need it in half angle formula. So I can make it the subject and I bring this one this side. So it will be 2 PR cos P is the same as Q squared plus R squared minus my P squared. So there I can divide it through. I only remain with cos P is equal to my cos P is equal to Q squared plus R squared minus P squared over 2PR. Now, this one I need it half angle. So from, I say from, is the same as my, since I need it in what? In terms of cos, it will be twice cos squared P all over 2 minus 1. If it was a double angle, then it could hurry us and we say just cos squared. But since this one is not a double angle, so we shall get the half of it then we express it in terms of that. So I will make sure that this one is the subject of the formula. So I will say, if I bring this one this side, it will be a plus. So it will be cos p plus 1. This cos is an angle. An angle member. Okay. So it's equal to twice cos, but squared into p over 2. So I will divide it through by this 2, and I make my cos squared p over 2 the subject by saying it is a half. It is a half cos p plus this one plus my one there. So I will come back. I will come back and I say, I'm so sorry, because now me making the subject here again, I just needed this. So I simply carry the whole of this and I substitute it here. I hope members you have seen. Sorry for that mistake. So here, I don't know whether the hand is moving faster than the brain. So here I will come and I say, since I have my cos p as this, so I will come and I substitute there. So it will be twice cos squared p over 2 minus my 1 is the same as my q squared plus r squared minus p squared over my 2p r. So I can now make this one the subject of the formula there. So it will be, since this is a negative, as it crosses, it will be what? A plus. Okay. So this is twice cos squared into p over 2, same as q squared plus r squared minus p squared over 2pr, then plus 1. So from there, still I'm not having this one as the subject, so I will divide by 2. I hope you have seen that. This is cos squared into p over 2 is the same as. Now, I hope we can agree, and I say this is the same as a half into. Now here we can simplify here from here, since we are pure mathematicians. So let us get the LCM here. This is all over 1, then we substitute at once. So the LCM it will be 2p and 2pr, isn't it? Now this 2pr divided by this remains the same. So we shall say this squared plus r squared minus p squared. Then this, the LCM divided by 1, it is that very one. Then this LCM times 1 will be a plus 2pr. Hope every person have seen that. Go to the next and then you see, we can, I think, enter this half inside. So my cos squared into p over 2 is the same as, if I multiply that half inside there, it will be now q squared plus r squared minus p squared plus 2qr all over my 4 p r. So now here I have got now one of the what? One of the needful thing there, which is that one. Now I don't know whether members can agree with me that the rest of the this one, if you look at it, still it is going to be in this form, but we are going to change now the variable. As the angle changes, also the variables here will keep on changing. But so for explanation, let us also go through another one, like for Q. Because here I have made now cos squared p over 2, I have got it. I will come and I substitute there. Also the same thing, it will happen on what? On Q. From my Q squared is equal to p, this time around, plus r squared minus 2pr cos Q Q. Hope there you have seen. Then now we bring this side. Hope members we can follow here and I just quote. This Sakazi we can follow and then I just quote it.
Yes, just quote, members will work out.
Okay. So this cos Q. Now let me just express direct following this format. I will have now cos squared into Q over 2 is the same as it will be my P squared plus R squared minus R squared minus Q squared, then plus my 2 P R all over 4 over 4. Let me see. All over 4 Q. Excuse me. Somewhere here, let me just come and I see. This is so members, I'm sorry here. There is a slight mistake. That's why I said it will direct us here. This one must be what? Q. Isn't it? So everywhere now we shall change. Where there is this 2, we shall put there what? It will be 2Q. Then here. Because I was saying there, that's helped us to even confirm our mistake. Hope every person is correcting. So we come here and then you also correct it. Yeah. So now this one, we shall depend on this, which is now here P R. Then also for cos squared R over 2 is the same as, so you will say this is the P squared Q squared minus IR squared, then plus 2 PQ over P over PQ. Yes, I'm not mistaken. So remember, since we have all of these expressions, we shall come where we started from, because we started by saying that the left-hand side is equal to that. So we shall come and then we carry this expression. This we shall plant it here. Then this shall also bring it here. Then that one also shall bring it there. I hope we agree, members. So we said the left-hand side is the same as 1 over P, 1 over P. But our cos squared, P over 2, we have it. So we shall say into Q squared plus R squared minus P squared plus my what? I2Q R over 4 Q R plus my 1 over Q into this one is the P squared R squared minus Q squared plus 2P R over 4 P Q. This is P R, then plus 1 over R into this is P squared plus my Q squared minus R squared plus 2 PQ over 4P Q. Okay. So members, now we shall come and we say, we can enter this one inside. Now as we enter this one inside, we shall see that. Okay, let me show. But no, from here, if we enter this P here, it will be 4 QR. And if I enter this Q here, it will be 4 PQR. And also if I enter the R inside, this one over R, because I'm just entering the denominator, it will become 4PQ, PQR. Implying that my LCM there, it will be what? 4PQR. Hope every person has seen. So let me put it here. Since I have the same what? I have the same LCM in the denominator. So I just add them up and I get what I'm looking for. So this one I'll just write everything on the numerator, which will become Q. So first, minimize it. So some of us are writing. I don't know. PQR. So this PQR, they have agreed that the LCM is the same. So the numerator should be just copied the way it is, adding them. So it will be Q squared plus R squared minus P squared plus QQR plus. Now, since there is no minus sign here, I can simply open that bracket. Yeah, because there is no limitation of changing signs inside. So it will be squared R squared Q squared plus 2 PR plus my P squared D 2 squared D plus 2P 2PQ. I hope members we are there. If we have done any mistake, then that thing will show us, will tell us where we have gone wrong, and we shall follow back and we will see. So let us simplify now. Because here I'm seeing there the negative and the positive. So which means there must be something right. Yeah, I hope we are together. So if I look at Q, let me search the identity of Q only. I have here Q for Q squared. I mean, here I have Q squared, which is here. Then my Q squared, where is it? Is here, and it is a negative. Hope you are saying it. Then there is another Q squared, which is positive. Implying that the negative and the positive, they will cancel. We shall ignore it out. So you have seen, I think, I'm sorry to show, but in the exam, don't show because here we are in the group. But when you are alone, you are facing the paper. Don't cross your work. Just leave it. Yeah, they will know that, yeah, this one went. So this and this have gone. And then we can follow also the R. Let us follow the R squared. So you have here positive R squared, you have positive R squared. That is now 2 R squared. Then you have another negative R squared somewhere, which is here. Implying that again, this R squared can reduce with that R squared, which is okay. That one we stop there. We can also look for P squared. Here I have already started now with the negative. So if I follow, I can have here positive and I have here positive. So this and that will cancel. So what I'm remaining with is R squared plus 2QR plus 2QR, and then here I'm having the this. So yeah, I'm having 2PR plus this one here. P squared plus Q squared then plus 2PQ over 4PQR. Now, members, we are there. So from here, you will allow me, and I give you something from up here, isn't it? So, since we have reached here, we have reached at the answer, but how do you see that answer? Let me show you from here. If I'm having a bracket, this PQ R but squared. If I can try to expand that bracket there, members, for sure you will see that we shall come where? Shall come at this numerator here. Let us try and we see. We shall first of all group these two together. And then we say now this is one term. And then this one we use the binomial there, which we shall now say this one is the same as my p plus q but squared plus 2r into my p plus q and plus my r what? Squared. Hope every person knows there. So we shall go on and we open up this one. So if we open up, we shall see that this is the p squared. Okay, let me mark it. So you are showing just here the side work. So here you have p squared plus 2pq plus q squared. Also I can open up here and I say 2rp plus this r can enter. So I have 2qr plus my r squared. Now members, let us come back and we see. Here, I'm having the r squared, which is here. I'm having my 2qr. So if we start it here, I'm having my 2pr. 2pr is the same as 2rp. Yeah, this one is there. I have my p squared, which is there. I have my q squared, which is there. And then lastly, I have my 2pq. So I hope you'll allow me. And I say this one here. Okay. If I had space, I could say, anyway, let me say it. But the r squared plus 2qr plus 2pr plus p squared plus q squared plus 2pq is the same as where since I said okay. Let me say now p plus r but squared. So I hope I have shown you how to come up with the whole of this. Then I now say my left hand side is the same as now where there is this numerator. I will put this one here. So I will say p plus q plus r plus squared over 4p2r, which is equal to the right hand side. Yeah? So our conclusion will be, therefore, the whole of this is equal to the right hand side. That's one. So that one was our part C. Our part C.
Okay, thank you so much. Thank you so much. It is clear. Just because we don't have time, you would have showed us how we expand that p plus q plus r, but it is clear. Thank you so much.
Okay. So maybe also the good, a candidate should not forget to say this, and then where the hand that you are starting with, you should be sure it's clear. Yeah, here as I have done here. So that was the one I had.
Okay, thank you so much. Is Mr. Erisa? Is Mr. Erisa around?
Has moved the call some distance.
Okay, it is okay. What about the other boy?
The other boy is still around.
Okay, let him come back. Let him come back. Yes, because he had a 2. And I kept asking, where did he get that 2? So I want him to repeat that number to make the correction.
Yes, come back.
I want you to repeat the number of 1 plus 1 plus sine squared x.
Okay,
that one, part B.
Part B of question 43.
Yes.
Okay, sir. Now, the question is, use T, the same one. Okay, by substitute, use the substitution T, which is the same as tan x, to find the integral of 1 over 1 plus sine squared x dx. Now, sir, I said that with this part, we are going to first of all use the part that told us to substitute, which is now t, which is the same as tan x. Now I'll depreciate this. When I depreciate this, I'll have the t the same as sec squared dx. Now in my function, the order that I've told you to find, I'll make the x the subject, which is the same as the x, the same as the t over sec squared x. Hey, I've forgotten here x. But sec squared x is the same as, this is the x, the same as the t over 1 plus tan squared x. Now, I have told you that by substituting t as the tan x, so where there is tan, I'll put my t that the question is telling me to do, which is the same as the t over 1 plus t. But my t, I mean my tan here is squared, so I'll square that t. So that's my dx. Now I'll come here on the function that told me to integrate that part of sine squared x. I can now generate it from maybe the double angles. I can generate it from double angles to get that idea to substituting. So now I can say that from cos 2x is the same as cos squared x minus sine squared x. But I'm aiming at making sine squared a subject, which means I should not have my cos, I should not have anything like cos. So this one also can be written as 1 minus sine squared x minus sine squared 2x, implying that my cos 2x is the same as 1 minus 2 sine squared x. I want to make sine squared x a subject, implying that 2 sine, this is 2 sine x squared, the same as 1 minus cos 2x. If I divide here by dividing all of this by 2, this and this equals sine squared x is the same as 1 minus cos 2x over. Now I can now get this and I'll touch it back there. So I'm going to have 1 over 1 plus now my sine squared, which is the same as this. This is the same as 1 minus cos x over 2. I move the dx, which is the same as dt over 1 plus tan, 1 plus t squared. So now I can get the LCM here. If I get the LCM, I'll have my integral as 1 over, this is now the LCM t over 1 plus squared. From there, I can now say that it's integral 1 over 2 plus. Now this one is giving me 3. This one is giving me 3 minus cos 2 theta. So now I will say that divided by my denominator, which is 2, and this one I multiply with my dt over 1 plus 2 squared. So now I can say that integral 1 over 3 minus cos 2 theta times. As I did I introduced a multiplication sign, it means I'm getting reciprocal, which is like this.
Now, that's where you are making the mistake.
Yes, sir.
That's where the mistake is.
This is where the mistake came from.
Yes. So you remove those two steps. You remove those 2 steps. Remove what you have written and the other one.
This one.
Remove that one. Then just remove divide by 2. Remove 2. Even that one.
Even this one. The whole thing.
No. Even the t. Even remove the t.
Yes, sir.
Remove the t. Remove that dt 1 plus t squared. Now say. Now that expression is the same. Even remove that expression. Let's do it at once.
This one are passive.
No. Now you say 1 divide by.
1 divided by. Okay.
Because the like when you write here this side as side work. Let's use side work. This side.
Yes, sir.
Okay, divide by 2 plus. Okay, that is 3. 1 divide by 3. Out of 2. Yes. Then dt 1 plus x. Then continue like that. That's how it's.
Thank you, sir. So now this is the t over 1 plus n squared. I mean t squared. So I can now get the reciprocal of this by introducing the multiplication sign. This is integral 1 times 2 over 3 minus cos 2x times the t over 1 plus, which is the same as integral 2 over 3 minus cos 2x times the t over 1 plus t squared. So with this cos is having x, I get my expression should be in terms of t. So now cos 2x the same as 1 minus t squared over 1 plus t squared in terms of t formula.
Now that is another mistake. How are you getting that one?
Now, so the reason why I'm saying that this is the same as this I'm seeing done is that if it was maybe out of 2, then these 2 inside would not be affected. I don't know whether I've interpreted it wrongly.
Yes, show us how you are getting cos x. You draw here a triangle. I want you to draw a triangle. This side, draw a right angle the triangle.
Like this?
Put x as one of the angles in one of the corners. Put x as the angle.
So I'm not getting you where.
Put x as the angle. Your angle is x. Show where we have t is equal to tan x. So I want you to show where is t on that triangle of yours.
I show where cos is. I mean
tan t.
Where
t. I want you to place t somewhere.
Okay, now this one we can maybe now introduce in maybe 1 here, and also 1.
No. Remember,
Yeah.
they have given us tan x is equal to t, right? Tan x is equal to t.
Okay.
That one. I want you to use that one. So where is t?
To use this one to get tan, show where tan x is coming from.
Yes.
Tan, the same as opposite over hypotenuse. Which means tan x, my opposite is going to be what? Going to be t. So I don't know whether I'm doing the right thing.
No, now tan is not opposite out of hypotenuse.
Sorry. And okay, from that Sokatoa. Which means it is opposite over adjacent.
So looking at your expression, what is your adjacent? Looking at your expression, what is your adjacent?
Adjacent, the same as 1.
Put a 1 there.
Adjacent is 1 here. Yeah.
Then find the hypotenuse.
Got the hypotenuse. So getting the hypotenuse means I'm going to apply, I will say this squared plus this squared, 1 squared plus t squared, the same one. Let me call my hypotenuse to be 6, which is 6 squared. So now this is 1 plus t squared, the same one, c squared. But I want c, which means my c is the same as square root of 1 plus t squared. So that is my hypotenuse.
Place it there.
Wanji?
Place it there up. Place it there.
Okay. So this is 1 plus t squared.
Now come back here and write cos 2x.
Cos 2x. So now cos 2x.
Is equal to, now I want you to first expand, is the same as what?
Cos 2x is the same as sine, cos squared x minus sine squared x.
Now, using your triangle, what is cos x?
Cos x, using my triangle, cos is the same as adjacent, which is 1 over hypotenuse, which is that. So it is the same as 1 over square root of 1 plus 2 squared.
Everything squared.
And then I square it.
Continue and find the sign. Yes.
Okay. Then I can also get the sign which is opposite. Opposite is t over the hypotenuse, which is square root of 1 plus 2 squared, but t squared. Implying I'll open that. Cos 2x is the same as, this is 1 over 1 plus t squared. Since now the square will go with the root. Then minus, this is t squared over 1 plus t squared. Then from there I'll get my LCM, which means cos 2x is the same as, this is 1 plus t squared. Then 1 minus t squared.
So that is how it comes about.
Okay, then yeah, just go to it direct that since I'm not like this, it is not maybe a upper angle is also the same as just cos x.
They are not the same. They are not the same.
Okay.
Mm.
Okay. Okay, thanks for this knowledge. So now I think from there we shall get our cos 2x and then we put in this here, which means we are going to have integral of 1 over we have reached which step? Yeah, here. So it is integral of 2 divided by 3 minus cos x, which is the same as 1 minus t squared over 1 plus 2 squared. Times dx, which is the same as dt over, this is 1 plus t squared.
Put a bracket between 1 minus t squared.
This one like this. So
Continue.
now I can go ahead and I get my LCM here. No? Yeah, I can do that. Which means it is integral 2 over, now since all these three is under the denominator, so I can get the LCM on the denominator, which is 3. The LCM I mean is 2, I mean 1 plus t squared. So this, when I divide by 1, I remain with this. Then if I put that t, if I multiply it with 3, I remain with 3 plus 3t squared. Then minus this divided by this, I remain with this, which is 2 bracket 1 minus t squared plus times the t over 1 plus t squared. So this is the same as integral 2 over, now this and this it is, okay, 3t plus 3 plus 3t squared minus 1 plus t squared divided by 1 plus t squared times dx, which is the same as t, the t over 1 plus t squared. So now I can simplify here by saying integral of 2 over, this is 2 plus 4 t squared divided by 1 plus t squared times the t over 1 plus t squared. Then from the correction, I think it is now integral 2 over, let me see, it is now integral 2 divided by 2 plus t4 t squared over 1 plus t squared times the t over 1 plus t squared. So this is also the same as 2 times 1 plus t squared divided by 2 plus 4 t squared times the t over 1 plus t squared. Now from here, I can now pull out my common terms and then the coefficient on the numerator, which is 2 over, since now this is 2 plus 4, I can now pull out 2 over 2 into t squared divided by 1 plus 2t squared times, oh sorry, mistake. Remember, this is the multiplication multiplying everywhere, which means this 2 is affecting everywhere there. So which means it is 1 plus t squared times the t over 1 plus t squared. Now from there, I realize that my questions out are cancelling, and also this is cancelled with this. So I remain with integral of 1 over, this is 1 over 1 plus 2 t squared times the t. Now, as I said earlier on, that we cannot just integrate this one to get in x because of this square. So we look for some knowledge. We can say that let 2 t squared equal to tan u, but squared also. Such that where there is 2t squared, I punch in this. I can now integrate that. If I mean depreciate, if I depreciate that, that is 4t, the t, with the same ones. But even if I do this, see that giving me the same answer. If I say 2t with the same ones, tan u. So now if I depreciate, I get 2 dt with the same ones, sec squared u du. I make the t the subject, so I will have the t.
Like I told you, there is something missing on that 2.
Yes, sir.
There is something missing on that 2.
On the 2.
Yes. How did you get 2t is equal to tan u?
Okay, I've just said that only 2t to be the same as tan u. Or I get the whole expression, the 2t squared.
Okay, continue. First continue. First continue and we see what you get.
Okay, now this is the same as sec squared u over 2. But u. So now I can now punch in, which is integral of 1 over 1 plus. Now my 2t is the same as tan u, which is tan u, but I'm left with the square.
Now, what you are writing is not correct. What you are writing is not correct. Remember here you have 2t is equal to tan u, meaning that if you substitute for your t is going to be tan squared u out of. Are you getting it? Hello?